Cik 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 cik. Cik 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 cik. Cik 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 cik. Cik cik cik. Halo. Lagi tinggi, lagi tinggi saja. Cik cik. Makanya dekat sekali mic-nya. Cik, di sini nggak batas.
Selamat datang di Universitas Tadulako.
Saya Profesor Dr. Insinyur Mahfud, Rektor Universitas Tadulako, perkenankan saya menyampaikan beberapa hal terkait pengembangan Universitas Tadulako ke depan. Yang pertama, bahwa keberadaan Universitas Tadulako sebagai perguruan tinggi yang berada di kawasan timur Indonesia yang sangat dekat dengan wilayah pengembangan IKN ke depan. Tentu selaku perguruan tinggi yang berada pada daerah IKN terdekat sangat berkepentingan untuk mempersiapkan kualitas sumber daya manusia agar bisa bersaing secara global. Yang kedua, bahwa cita-cita kami untuk mewujudkan Universitas Tadulako berkelas internasional atau world class university. Tentu kami harus banyak mempersiapkan hal-hal yang terkait dengan hal tersebut, di antaranya mengembangkan program studi, sistem pembelajaran, dan fasilitas penunjang pembelajaran yang tentu juga harus berskala internasional. Selaras dengan hal tersebut, Universitas Tadulako juga berkomitmen untuk berperan aktif dalam pembangunan nasional dan memberikan yang terbaik untuk anak bangsa kita ini. Semoga Universitas Tadulako ke depan semakin maju dan berkembang dan bisa berkompetisi di skala nasional maupun internasional. Mari kita sama-sama bekerja sama untuk mencapai cita-cita yang kita harapkan ke depan. Demikian, wassalamualaikum warahmatullahi wabarakatuh.
Berdiri pada tahun 1981 sebagai universitas yang mengemban tugas mencetak generasi unggul dan profesional. Seiring dengan kebutuhan pendidikan dan laju zaman yang kian melesat, Universitas Tadulako menjadi pusat pendidikan yang berkualitas di Sulawesi Tengah. Untuk mewujudkan tanggung jawab tersebut, Universitas Tadulako menetapkan visi. Universitas Tadulako menjadi perguruan tinggi berstandar internasional dalam pengembangan iptek berwawasan lingkungan hidup. Perjalanan Universitas Tadulako selama 4 dekade dimulai dari Universitas Tadulako berstatus swasta pada tahun 1963 hingga tahun 1966. Universitas Tadulako berstatus cabang pada tahun 1966 hingga tahun 1981. Kemudian, Universitas Tadulako berstatus negeri pada tahun 1981. Universitas Tadulako memiliki ribuan mahasiswa yang berasal dari daerah di seluruh Indonesia, serta dosen dan tenaga kependidikan yang berkompeten di bidangnya. Saat ini, Universitas Tadulako memiliki 11 fakultas dan pasca sarjana, dengan jumlah 82 program studi yang telah terakreditasi oleh Badan Akreditasi Nasional Perguruan Tinggi.
Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Ilmu Sosial dan Ilmu Politik, Fakultas Ekonomi dan Bisnis, Fakultas Hukum, Fakultas Pertanian, Fakultas Teknik, Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Kehutanan, Fakultas Kedokteran, Fakultas Kesehatan Masyarakat, Fakultas Peternakan dan Perikanan, Program Pasca Sarjana memiliki 18 program magister dan 5 program doktoral.
Universitas Tadulako memiliki segudang prestasi, baik akademik maupun non-akademik. Yang pertama, memenangkan program kompetisi merdeka yang diselenggarakan oleh Kementerian Pendidikan, Kebudayaan, Riset, dan Teknologi. Kedua, Universitas Tadulako juga berkesempatan mengikuti program Indonesian International Student Mobility Awards atau ISMA yang merupakan bagian dari program Merdeka Belajar Kampus Merdeka, Kementerian Pendidikan, Kebudayaan, Riset, dan Teknologi. Ketiga, mahasiswa Universitas Tadulako berhasil menjadi salah satu delegasi peserta Pertukaran Pemuda Antar Negara atau PPAN Indonesia Korean Youth Exchange Program. Keempat, mahasiswa Universitas Tadulako meraih 2 medali emas pada Bali International Choir Festival 2022 yang diikuti oleh paduan suara berbagai negara.
Paduan suara mahasiswa Universitas Tadulako PSM Untat
ditunjang dengan fasilitas unggulan dan dukungan teknologi informasi yang modern, di antaranya tidak hanya itu, Universitas Tadulako memiliki fasilitas penunjang ekstrakurikuler, olahraga, seni, dan budaya yang diperuntukkan bagi mahasiswa dan masyarakat. Di era 4.0, Universitas Tadulako terus meningkatkan pelayanan dan kualitas lulusan dengan menerapkan sistem digitalisasi. Pasca bencana alam, gempa, tsunami, dan likuifaksi tahun 2018, serta pandemi COVID-19 selama 2 tahun, kini Universitas Tadulako kembali berbenah dengan membangun sarana dan prasarana yang rusak akibat bencana. Program Merdeka Belajar Kampus Merdeka atau MBKM memungkinkan mahasiswa dapat mengikuti program belajar di luar program studi. Universitas Tadulako telah menerapkan program ini sejak diluncurkan oleh Menteri Pendidikan, Kebudayaan, Riset, dan Teknologi. Dalam rangka mengembangkan Tridharma Perguruan Tinggi, Universitas Tadulako menjalin kerjasama, baik dalam maupun luar negeri. Universitas Tadulako berkomitmen menjadi perguruan tinggi yang unggul, mengembangkan Tridharma Perguruan Tinggi hingga mampu mencetak generasi penerus yang berkualitas demi kemajuan negeri tercinta, Indonesia.
1G.
Cek. 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 Mic 1 cek. 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 Mic 1.
tes satu, tes satu, tes satu, tes satu.
Cek.
Ladies and gentlemen, you may now take your seat. Ladies and gentlemen, as our warmest greetings to you, we will present a traditional Kailinese dance of Central Sulawesi known as Mokambu dance, choreographed to symbolize blessing from the God Almighty and to welcome you all, our distinguished guests who came to the city. Danced by 5 young girls and using traditional musical instruments named kakula, gimba, and gong. Presented by Sanggar Seni Pitate of Faculty of Agriculture, Tadulako University. Ladies and gentlemen, this is Mokambu Dance. Enjoy the show. Ladies, Cheek. Ladies and gentlemen,
Cek, cek.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, salam sejahtera, Om Swastiastu, Namo Buddhaya, salam kebajikan, Rahayu. Honorable Rector of Tadulako University, Bapak Profesor Dr. Insinyur Haji Mahfud, MP, Dean Faculty of Agriculture, Tadulako University, the member of consortium, our distinguished guest, also the keynote speakers of this international conference, Professor Grass from University of Hohenheim, Germany, Dr. Husnain from Indonesian Center for Agricultural Land Research and Development, Associate Professor Christiansen, University of New England, Australia, Professor Kasem Sap from Kasetsart University, Thailand, who are joining this event virtually by Zoom. Last but not least, Dr. S.C. Agr Ayan Choa from Tadulako University, Indonesia. Director of Postgraduate, Deans, all the speakers, community participants, ladies and gentlemen, welcome to the Convention Hall of Swiss Bell Hotel, Palu, for the opening ceremony of the 3rd International Conference on Environmental Ecology of Food Security 2023. Dealing with the issue, the future of food and agriculture, is there any chance to be sustainable? Held in Palu on 14th till 15th February 2023. Ladies and gentlemen, this conference is held to discuss various issues and research results in science and technology. Apart from being a momentum in responding to the issue of the threat of a global food crisis, carrying out the responsibility of the research profession to play a role in the development of agriculture science and technology and agricultural socio-economics for the national interest and Central Sulawesi province. Ladies and gentlemen, this event is also a part of the cooperation of the Faculty of Agriculture from several universities in eastern part of Indonesia. It is expected to exchange knowledge as well as building a networking to solve the global problems. Honorable, distinguished guests, speakers, participants, ladies and gentlemen, we would like to commence this program by singing the national anthem of Indonesia, Indonesia Raya. Please all rise.
Aku berdiri dari Bandung, Indonesia kemanjakan, saya terangkan.
Thank you very much. Kindly be seated. Ladies and gentlemen, I would like to invite Saudara Riko Firman,
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us bow our head for a moment, pray to God Allah Subhanahu wa Ta'ala so that our international conference can be precious to all of us. I will let us pray based on the teaching of Islam, and those who are not Muslims, you are placed to pray according to each of your beliefs. Alhamdulillahi Rabbil Alamin, hamdan yu'afi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi lil jalali wajhikal karimi wa azimi sultanik. Allahumma inna nas'aluka salamatan fid din wa afiatan fil jasad wa ziyadatan fil ilmi wa barakatan fil rizki wa taubatan qoblal maut wa rahmatan indal maut wa maghfiratan ba'dal maut. Allahumma ighfir lana wa liwalidina walil muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i minhum wal amwat innaka sami'un qaribum mujibud da'wat ya qadiyal hajat. Oh Allah, today, Tuesday, February 14, 2023, in this beautiful place, we gather here to bring about the third international conference on environmental ecology of food security. Ya Allah, make this international conference as a useful science assemble, as a medium of sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our lives, broaden our knowledge, shine our ideas, and lead us to be successful, productive person, which in turn will boost dignity of our nations. O Allah, guide and bless our hearts and our minds with the light of your guidance. Impart your supreme wisdom upon our activity. Help us to speak our minds clearly. Help us to listen to each other, respect each other, love each other, so that we are included to the blessed person. O Allah, protect us from unintended temptation. Show us the right path and give us knowledge and strength to perform good things. Equally, show us and make it clear the bad things and give us knowledge and strength to avoid them. O Allah, you are the one who can fulfill our dua. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Amin amin ya rabbal alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Distinguished guests, ladies and gentlemen, distinguished guests, ladies and gentlemen, without further ado, please help me welcome the chairman of the Third International Conference on Environmental Ecology of Food Security, Organizing Committee, to deliver a remarks. Bapak Profesor Dr. Insinyur Abdul Rahim STP MP, IPM, ASEAN Engineer.
Assalamualaikum warahmatullahi wabarakatuh. Saya ulangi. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much. Alhamdulillah nahmaduhu wa nasinuhu wa nastaghfiruhu wa na'udzubillahi min sururi anfusina wa min sayyiati a'malina may yahdihillahu fala mudhillalah wa may yudlil fala hadiyalah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma salli wa sallim wa barik ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in, amma ba'd. Dear Honorable Rector of Tadulako University, the Honorable Dean of Agriculture Faculty Tadulako University, the Honorable Keynote Speaker both online and offline, the Honorable Dean of Agriculture Faculty Haluleo University, Mataram University, Musamus University, Al-Khairat University, Muhammadiyah University, the Honorable Director of Postgraduate Tadulako University, thank you very much, the Honorable Dean of Faculty of Tadulako University, and the honorable invitation participant. We warmly welcome the presence and participation of all in the 3 international conference and environmental ecology of food security conference with the theme, the future of food and agriculture. Is there any chance to be sustainable? Organizing this international conference is one of the commitment to provide quality education at the Faculty of Agriculture. This conference is held to discuss various issues and research results in science and technology, especially agriculture science and agriculture social economy agribusiness. Learn from university that have been successful in transforming their progress. We are sure that this conference will contribute valuable idea for the campus growth and development in broad sense, especially in the central Sulawesi region. The total number of researchers participating both online and online are 165 presenters from BRIN and several universities such as Mataram University, 11 Maret University, Musamus University, Haluleo University, Mahaputra University, Muhammad Yamin Andalas University, Mataram North Sumatra University, Palangkaraya University, IPB University, Maharasaswati University, Hasanuddin University, and of course Tadulako University. The committee has coordinated with the IOP, publisher, and effort from us so that the scientific work that will be presented in Palu City for 2 days will have an impact on agriculture development on a sustainable global scale. From Palu City, we made an impact on the world community, and from the 2-day meeting, we made a lasting impact on current and future generation. That was the committee report from my side. Thank you and welcome. I hope all participants are enjoying in Palu City, especially from Mataram University, Musamus University, and Udayana University. I hope Rector of Tadulako University, to opening this national conference today. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, continuing to our next speech, I would like to invite the Dean of Faculty of Agriculture of Tadulako University, Bapak Profesor Dr. Insinyur Muhardi MP, IPM ASEAN Engineer, as the host of the third ICEFS 2023.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Good morning to everyone present here. Thank you in advance for joining us at these 2 days, the third international conference on environmental ecology of food security, ICFS. Dear Honorable Rector Tadulako University, dear Honorable our Canadian speaker, Professor Dr. Engel Grace from University of Hohenheim, Germany, Dr. Husnain, MP, MSc from Indonesian Center for Agriculture, Land Research and Development, Associate Professor Christiansen from University of New England, Australia, Dr. Ian Choa from the host of this event, Faculty of Agriculture, Tadulako University, Indonesia, and Professor Kun Paipo Kasensap, PhD, from Kasetsat University, Thailand. Dear Honorable Head of Department and Central Sulawesi Province, dear Honorable Head of Higher Education members of the ICEFS, Deans of the Faculty of Agriculture in Sulawesi, Nusa Tenggara and Bali region, Director of the Goa Folk Bangtan and the Head of LPP Nusamus University, and to all of members of the ICEFS 2023 Consortium. Welcome to Palu and Tadulako University. Dear Honorable Director of Postgraduate Tadulako University, thanks for coming. Dear Honorable Dean, all faculties from Tadulako University, and participants attending the third International Conference on Environmental Ecology of Food Security, ICFS. Praise and gratitude we pray to Allah Subhanahu wa Ta'ala, God Almighty, for the gift and help and the opportunity given so that we can participate in the third International Conference on Environmental Ecology of Food Security, ICFS. This conference is hosted by the Faculty of Agriculture, Tadulako University. This conference is collaborated with Agricultural Faculties Association in Central and Eastern of Indonesia. Today's conference is delivering theme, the future of food and agriculture. Is there any chance to be sustainable? Apart from being a momentum in responding to the issue of the threat of a global food crisis, this conference is also carried out as a form of carrying out the responsibility of the research profession to play a role in the development of agricultural science and technology and agricultural socio-economics for the national interest and Central Sulawesi province. The Faculty of Agriculture should be make a more concrete and valuable contribution to global and national agricultural development, not only in the form of increasing human resources, but also from the aspect of improving and applying agricultural technology which can directly benefit farmers and human population. The theme of this year's conference also internally reinforces the direction and accelerates the achievement of the Faculty of Agricultural UNTAD vision, global competitiveness in the development of science and technology and innovation to support sustainable agriculture. The application of this concept of sustainable agriculture is a must. Even though currently the potential of agricultural resources is still huge, with needs that also increase exponentially, sustainable farming practices are necessary for our help to succeed. Welcome to Palu, Indonesia. I hope you enjoy the conference, and I believe that we can contribute something valuable to think and share about food security worldwide. That's all to conclude my remarks, and I would like to request the Rector of Tadulako University to formally declare and open the conference officially. Thank you very much. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Distinguished guests, speakers, participants, ladies and gentlemen, it is now my pleasure to invite to the podium Rector of Tadulako University, Bapak Professor Dr. Insinyur Haji Mahfud MP, to deliver a keynote speech, and afterward, we would like to request the Rector to officially open the 3rd International Conference on Environmental Ecology and Food Security 2023 by hitting the gong.
Tes, tes. Nggak ada. Tes.
Cek, cek. Cek, cek.
Ladies and gentlemen, good morning. Once again. Good morning. Thank you so much. Bismillahirrahmanirrahim. Assalamualaikum wabarakatuh. Salam sejahtera buat kita semua. Om Swastiastu.
Check this.
Distinguished guests, fellow speakers, session presenter, participant, and audience joining this conference online. First, may I thank our speakers for the third International Conference on Environmental Ecology of Food Security in the morning session, namely Profesor Fajri, yang dalam hal ini diwakili oleh Dr. Husnian MP MSc, Profesor Valo Christiansen from University of New England, Australia, and Dr. Ian Shaw, Agriculture Faculty of Tadulako University. And key speakers in the noon session, Professor Fun Vivo Kasesam from Kasestat University, Thailand, and from Professor Ingo Gras, University of Hohenheim, Germany. I would also like to thank our valuable guests, session presenters, and participants such as the deans from UHO University, Mataram University, Musamus University, Undana University. This conference topic is about the urgent task for the university, in particular faculties related to life sciences such as agriculture, environmental sciences, animal sciences, etc., to contribute to teaching and education in science and technology development. Also, new concept on sustainable production and consumption of our food. We are often out of harmony with nature in thriving ecosystem. Unsustainable production and consumption are sending emission skyrocketing and degrading our land, sea, and air, making it harder to feed growing population. Ecosystem degradation comes with a steep human cost, a cost in lost jobs, hunger, diseases, and death, a cost in higher prices for water, food, and energy. People is responsible for this destruction are always the first to feel the impact. We know food and nutritional security and foundation of decent life. And by 2050, our planet may be home to 9.1 billion people, over 2 billion more than today. In Indonesia, maybe need to feed 331 million people in 2050. Ladies and gentlemen, rising energy prices drove up the cost of food and outweigh the saving that people otherwise would have spent on health care or education. It is a vicious cycle that impoverishes not only its immediate are declining. Weather is often unpredictable. Weather unpredictable and extreme. Food security and climate change are deeply interconnected. We must make significant change to produce food, and university plays significant roles in improving education system and science development. Education helps to build the capacities needed to implement sustainable development strategies. Education is key to achieving the result of many of the sustainable development goals. University policies, faculty awareness, curricula, research and partnership from various disciplines and academic units are key to produce sustainable food. Ladies and gentlemen, let me once again thank our key speakers, presenters, and participants, university leaders. Last but not least, I thank heartily the organizer, the Faculty of Agriculture of Tadulako University, and the conference organizer, team lead by Professor Abdullahim, have a successful conference, fruitful discussion, and produce tangible outcomes. Demikian, wassalamualaikum warahmatullahi wabarakatuh.
Satuji. To accompany, please remain on the stage. The Dean of Agriculture Faculty, I also would like to invite the member of consortium, the Agriculture Universitas Hasanuddin, Agricultural Faculty, Universitas Mataram, Agriculture Faculty, Universitas Haluoleo, Agriculture Faculty of Universitas Nusa Cendana, also the Chairman of the Research Development Institutions of Musamus Merauke University, Director of Postgraduate Deans, please come to the podium.
And the name Allah Subhanahu wa taala, the third International Conference on the Environmental Ecology and Food Security is open. Cocok di. Bismillahirrahmanirrahim. Apa ini?
Ladies and gentlemen, I would like to request Director of Tadulako University to deliver a token of appreciation to the member of consortium. Sekali lagi masih tetap di podium. Untuk selanjutnya kita akan menyaksikan penyerahan cindera mata kepada anggota konsorsium yang hadir pada kesempatan pagi hari ini. Gong, Rian. Itu gong. Gong. Boleh kamu ambil dulu gong, Dek? Appreciation delivered by Director of Tadulako University to the member of consortium. I would like to invite the Dean of Agriculture Faculty, Universitas Mataram. The Dean of Agriculture Faculty of Universitas Haloleo. The Dean of Agriculture Faculty of Universitas Nusa Cendana. Ketua Lembaga Penelitian dan Pengabdian pada Masyarakat Universitas Musamus Merauke. Last but not least, I would like to invite Ibu Dr. Ayen Chowa as the representative of the keynote speakers today. Terima kasih, mohon tetap di podium untuk kami abadikan sejenak dalam foto kenangan. We would like to take a picture first. Dekan Fakultas Ekonomi mohon perkenan, Pak D bergabung di podium, di panggung. Also Profesor Alam Ansari. Thank you very much. And kindly be seated. Terima kasih Bapak Ibu. Kami silahkan kembali ke tempat semula. session today in this international conference. To add more flavor of Indonesia to this program, we would like to present a Wonderland Indonesia dance, The Sacred Nusantara, combining the 8 songs from Bali, Kecak, Jawa, Lingsir Wengi, Cik-Cik Periuk, Kalimantan Barat, Sinanggar Tulo, Sumatera Utara, Ayo Mama, Maluku, Angin Mamiri, Sulawesi Selatan, and Lalo Ngaro, Sasak, Lombok Timur, danced by Sanggar Seni Pitate of Faculty of Agriculture. Ladies and gentlemen, enjoy the show.
There was a princess who lived in a beautiful land, which everything in it lived peacefully. She spent all her time in the depth of a forest with her 8 little friends. There was a hidden secret place, so magical and dangerous at the same time. This is the story where the culture had start. And now, let me take you on a journey. So welcome to Wonderland, Indonesia, the sacred Nusantara.
Hadirin yang kami hormati, ladies and gentlemen. Next we have a coffee break for 5 to 10 minutes before going to our first session today. Ya, mohon panitia bisa menyediakan kopi ataupun juga teh di meja VIP. ke tempat duduk masing-masing. Kita akan ikuti sesi berikut pada pagi hari ini karena pemateri atau pembicara kita telah siap di link Zoom yang sudah tersedia. Sambil menikmati cafe break pada kesempatan pagi hari ini, kita akan lanjutkan acara. Bapak Ibu yang kami hormati, ladies and gentlemen, we come to the very first session of this international conference, the panel presentation of keynote speakers, and this session will be chaired by Bapak Nur Edi, PhD, as the moderator.
Assalamualaikum warahmatullahi wabarakatuh. May I have your attention please? I would like to invite Ibu Dr. Ayen Chowa to come together with me here on the stage. We would like to start the first session immediately. All right, ladies and gentlemen, our panel keynote session of the conference will begin soon. My name is Nur Edi, and I will be your moderator for today's seminar. Ladies and gentlemen, this is the third international conference on environmental ecology of food security, hosted by Faculty of Agriculture, Tadulako University, in collaborate with Agricultural Faculties Association in center and eastern part of Indonesia. Ladies and gentlemen, I'm very pleased to see all of you here and welcome to this conference. First of all, just to briefly explain about this event, the ICEFS, or International Conference on Environmental Ecology of Food Security, is an annual event conducted by the Faculties of Agriculture Association in eastern and center part of Indonesia. And this year, we would like to talk about the future of food agriculture. Question mark, is there any chance to be sustainable? We have 5 topics related to the conference. First of all, agricultural production, agricultural socio-economics, climate change, mitigation and policy, innovation and precision farming, ecosystem function and services. And luckily, we have 5 respectable keynote speakers for today. In the first session, we will have Associate Professor Paul Christiansen from University of New England, Australia. And the second speaker will be Ibu Dr. Husnain from Indonesian Center for Agricultural Land Research and Development. The third speaker, the only speaker together with us here today, Ibu Dr. Ayan from Faculty of Agriculture, Tadulako University. In the afternoon session, or in the second session, we will have Professor Dr. Grass from University of Hohenheim, Germany, and the second speaker in the second session will be Professor Kasamsap from Kasetsat University, Thailand. So, ladies and gentlemen, let's move to the first session. So before we start, I hand over to the first speaker. I will explain first the rule. So each speaker will talk about 20 minutes parallelly. Then we will continue with the discussion session. So I would like to ask for Dr. Powell. Are you with us now? Hello, Dr. Powell. Are you with us now? Can you say something that we can hear your voice, please? Panitia, mohon suara Dr. Powell di-on-kan? Okay. So before Dr. Christiansen deliver his topic for today, I would like to introduce him. He is Associate Professor in Agricultural System, University of New England, expertise in rural development, horticultural science, biostatistics, and research and development training. For almost 20 years, Paul has had a strong interest in livelihood transformation and adaptive capacity in the context of change in climate, society, technology, and agribusiness. He has supervised 80 postgraduates to completion, co-authored almost 90 journal articles, and attracted funding worth almost $10 million. With over 10 years experience in South and Southeast Asia, he has participated in numerous projects related to farming system and land use and livelihood impact, natural resources management, ecotourism, marketing, and value chains and policy analysis. Today, he will talk about challenges for agriculture and sustainability. Dr. Pyle, are you all ready?
Yeah,
Dr. Christiansen. Okay,
thanks, Pat.
great.
Thank you very much.
Okay, please have your time for 20 minutes.
Hang on, where's my Here we go. You can see the screen there? Okay, great. Thanks very much to everyone for organising the conference, and I'm really sorry that I can't be there. I was in Palu a few years ago and really enjoyed visiting the university and the area and looking around, and I'm sorry that I couldn't come and be with you today or for the conference, but thank you to all the organisers and the convener now. So, thanks very much. Okay, it's a big challenge, a big question. When I think about can we do it, I think about a lot of in history, a lot of civilizations, ancient Egypt, ancient Rome, have sort of come and gone, and whether it be ancient America one day or something. But so civilizations come and go, but people stay and communities stay and still sort of manage through all sorts of challenges. So I'm sort of hopeful that we will be able to say yes. It might not be in the forms exactly that we have become used to in the last sort of 100 years of development, but I think we have a lot of capacity these days, knowledge, technology, but human capacity to manage these challenges. And they're big challenges. They were sort of covered earlier, I think, by the rector covered them. We've got increasing population was spoken about, so so there's more mouths to feed. Longevity, so we're living longer. So those more mouths need more food for a longer period of time. Affluence, we want fancy stuff as we sort of move from large sections of poor to middle class to even upper class. We want more. We want richer foods. We want foods all year round. We're not worried about seasons. So affluence is a real driver of consumption as well. Dietary expectations, again, we want fancy food. We don't want, or even like here in Australia, we often chop off parts of the food and throw it away, so we have a lot of waste. So that's, there are real issues around. So even if we're producing it, a lot of it, the number that goes around is 30% waste. So these are real pressures that we're facing. At the same time as demand's going up, resource capacity is pretty much going down for all sorts of reasons. Urbanisation or the spread, we're building more roads, more car parks, more houses, more shopping centres, things like that. So just taking up good land, and humans tended to settle in valleys and where there was good productive land, and you could grow crops like rice or wheat or key staples, and then all that good land is getting covered in concrete and buildings and so on. So, and there's not a lot. All the good land has been used. I know in Australia, if we see forest, it usually means the land's not very productive. So if it is productive soil, it probably was cleared and is farmed. And I think that's the case in large parts of the world. There's still big areas of wilderness, and certainly in Indonesia there are, thankfully for you. But we need to keep those resources for other reasons, for biodiversity and for the lungs of the world to absorb carbon dioxide. So we can't just keep clearing and so on. Water quality, soil quality is in most areas is under constant degradation through salinisation, through acidification, just through erosion, so loss of it, water pollution from industry, from domestic, from the erosion and so on. So we have all those challenges. So the resources, the soil and water that we really rely on to drive agriculture and food production are challenged. Climate change is I think the big thing that's looking with climate change are the extreme events. If it was only just increasing temperature and maybe varied rainfall patterns, we could possibly adopt to that. So we may have to move where we grow certain crops, but maybe the time frame is something that we can adapt to as humans. That maybe not every animal and plant can adapt. However, climate change, the real threat seems to be these extreme events that are becoming more common: very hot, very cold, too much rain, drought, floods. They're looking like major challenges. And then the new one, obviously, is COVID, messing up our lives, our day-to-day lives, with restrictions on travel, being able to do business, and then also interfering with supply chains and the availability of goods and services. So that's sort of a new one that we probably need to start to think about as well. Underpinning a lot of the development of agriculture in the last 100 years has been what we'd call cheap fuel, so cheap fossil fuels largely. That's changing too. I don't know what the price of petrol, how much it's been changing in Indonesia, but in Australia it's gone up quite a lot. Not double, but actually, yeah, pretty much double. So in the last few years, and we sort of know the global business reasons with conflict in Europe and so on, so and other places. So cheap energy, we need to really start to think about how do we get our energy in a sustainable way, a low or zero carbon way, and how do we make that available where it's needed. So we've been sort of riding off like in a lolly shop or a candy shop, having something that looked cheap and would go on for a long time, and now we're realizing no, that's not the case. So yeah, there's these challenges, and they all sort of come together as a real issue for us to deal with, and that's what the conference is about today. I probably won't labour these points too much, but just so here we've got increasing population, log scale, so it's really going up very high, this sort of area here. And that sort of graph of population is mirrored by a few other things like herbicide resistance. A lot of my work, my sort of production work has been on weed management. And and I do a lot of work on organic or non-chemical weed management. I think herbicides have a big role to play, but they really have that risk of herbicide resistance. So the tools that we've used for agriculture may be not what we'd always dreamt of, or we're reaching the limitations of those tools. Fertilizer, for example, which it has a lot of energy in it to make the fertilizers. And then things like herbicides, pesticides, so insects and so pests and diseases, they evolve, and they're always evolving. Even as we come up with one set of tools, that they evolve and develop resistance, and then we need to continue that struggle, I guess. The other areas, this is going back to the cheap energy. This is peak oil. This was predicted in 1956 that around 2000 there would be a peak in oil production, and after that it would decline. So that's 2000 there. I think it was a bit later. There was some undiscovered reserves or better extraction methods, so that's pushed on a bit. But we're really on the downside of cheap energy, as we realise. I'm hopeful that we will get our act together on renewables, on solar and all over Australia. And I presume it's wind and solar are really big investments in those that are going ahead. They're not the only answer, but I think we need to have a lot more options for energy production sustainably. Similar thing with phosphorus. So phosphorus, nitrogen we can get from the air. We can sort of fix nitrogen in either through legumes or through large energy inputs. Phosphorus we can't. Phosphorus is another key macronutrient that is a finite or a limited resource that we have to manage carefully. So are we going to get peak phosphorus as well? So we have this peak and then a decline. Or how can we recycle phosphorus? So, and that's something that what I'm going to talk about in this talk is locally grown seaweeds, and you'd know about that in the area around Palu and central Sulawesi where the production is. So I'll talk about that. And we need to think more about local resources, and now they talk about circular economy, but closing loops. So things like phosphorus, mining it, bring it from another country, but then how do we close the loops and not lose it out into the waterways and into the ocean and so on, where it's gone for pretty much for many lifetimes. So big challenges, but like we sort of said here, there's maybe there's options around energy, maybe there's better ways for fertilizer or nutrient use efficiency, more integrated weed management methods that we can start to develop to achieve our overcome the constraints in agriculture. So one of the biggest things that farmers do is controlling pests and diseases and weeds, so crop protection, and maintaining soil fertility. They're the sort of the big day-to-day challenges. Chasing dollars and good prices is obviously a big one, but day-to-day, the crop management, whether it's a intensive vegetable system or an orchard, so a perennial system, or pasture for stock production, fertilisers are very important. We've largely relied on chemical or synthetic fertilisers, but they can have costs. I think at the moment, due to the rise in energy costs, the cost of other farm inputs, particularly fertilisers, but also crop protection products have gone up quite a lot. And so there's economic concerns, but also environmental concerns about what does it do to the environment, to soil degradation, or if the fertilisers move off the farm into waterways, what about the implications for biodiversity, water quality, and so on. So we really need to be using chemical fertilisers carefully. They're a valuable, powerful tool, but we need to use them carefully. So really efficient fertiliser use. And there's a lot of technology that will emerge around new sensors, new being able to, get drones and go over and see what's going on with soil fertility. So new technology, but still basic good agronomy will be needed, so that matching the need of the plant with the availability of fertilisers. One of the things that I think is important in when I work in Southeast Asia is looking at what are local resources that can be used. So they might look like a waste product. How can that be or how can it be processed and reused in agriculture? And so things like biofertilizers, that could be anything from manures, composts, a whole lot of different sort of products depending on where you are and what are the waste streams. So if they're waste, they're potentially cheap, maybe. They'll be locally made, so hopefully not too much transport costs. We don't want to be shipping things that are full of water, like composts and manures. And they're from materials that are waste, so they may actually be a pollution or some sort of disposal problem in their own right. So we're trying to reduce that issue by using it somewhere else. A lot of them are not really high in macronutrients or even micronutrients. They're probably more a soil conditioner, so they're high in carbon, but not necessarily, they may be, but not necessarily high in NPK, nitrogen, phosphorus, potassium, and so on. So they'll almost always be a very good source of soil carbon. And so carbon's really important, not because of the politics of climate change, but because carbon in the soil holds onto water, holds onto nutrients, helps soil biology to function. And so it has many benefits in soil to increase the carbon level. So there's a lot of benefits, sort of social, environmental, and farming benefits. So they're potentially cheap. It's also potentially expensive. So it may have high transport costs, or it may be a waste because it's just not economic to try to repurpose it or to process it, to get it into a usable form may be too expensive. Spreading it on unprocessed may not be viable, or maybe just too expensive. Even something as simple as manure, trying to spread that around maybe takes a lot of time, or you need some machinery. So it's not necessarily cheap. It may be, may not be. Also, the advantage of commercial fertilisers is we know exactly what's in the bag, assuming it's not fake fertiliser. We know that the quality and the concentration of the elements that we've bought, we know what they are, what level. With these biofertilisers, they can, one batch this week might be different to next week or next month. How you're blending it can change things and so on. So you're not getting the same quality all the time and the same concentration. So the way you rely on it and what you use it for, then you have to be careful. If you're relying on exactly a certain amount of nitrogen, then this is not necessarily the way to go. And also the supply. So if it's a seasonal, like a crop residue, you might get a lot in over a couple of months and then get none for the rest of the year. So it's not always around. So it'll depend on what's going on. There may be some industries that are going all year round, others not. So there's limitations on how it might work. One of the things that I've been working with colleagues at UNTAD is seaweed, using seaweed as a biofertilizer. So I've been working with Ramal Yusuf probably for 10 years or more when he did his PhD and Masters in Australia, and then I've gone over there and we've worked together on quite a lot of research looking at this. And I'm going to present a little bit of what we've done, but I just want to make this a more general talk today. But so in the area throughout many parts of Indonesia, this is where we visited just not too far from Palu, other parts in Bali, around Southeast Asia, also globally in Australia too. Seaweed washes up on the shore. It performs a important function. We might sort of see that as waste and people can collect that, but seaweed performs a certain function in terms of nutrient cycles and so on. Here we're looking at seaweed farming. So this stuff in Canada just grows and washes up on the sea. Here it's farmed. It's used for, do I talk about that next? I think I'll talk a bit about that. So it's used to extract some particular chemicals, particular compounds that are used in the food industry, carrageenan, for gelling agents and so on. So they're widespread. They grow in the seawater, so the nutrients are there, the light and so on, the things that they need are there. There's many different species. So when we talk about this, a lot of the work on seaweed, what species are we talking about and what were the conditions that it was grown under is important. But here we've got something that's grown locally, a particular compound is extracted, and then there's a waste product afterwards. Something I didn't know, but actually seaweed farming is carbon negative. So it has an overall absorbing or sequestration of carbon. So it's even good in that sense. So it's a good little industry for small holders as well. And a nutrient accumulator. So it's a resource that's there. It's a resource that potentially has value for agriculture as a biofertilizer. Lots of different formulas and formulations and commercial products. I think this was just a screenshot. I probably did seaweed products in Google Images and sort of got this. So there's a whole lot of different products and made all around the world and different ways to extract it. And all of those things will have a big impact on the efficacy of seaweed and their extracts as biofertilizers. I've used seaweed just straight from the field. I'll go down the beach and put in the back of a trailer. I don't even wash the salt off and put it on soils. Where I grew up, it was very sandy soils, and I'd put them in there and just try to build up the carbon and no processing whatsoever. So very simple. But more commonly, there's liquid extracts or dried and powdered materials. So trying to kind of standardize the product, standardize the physical nature of it, and the chemical nature of it as well, and put in a form, maybe as a concentrate that is then easy to ship around, move around, and then add water at the end use point. Commercially farmed for carrageenan for the food industry. With potential use. So that's the form. So it's quite a well-known thing. Surprisingly, there's the research on it though is fairly patchy. There's not like if we look at urea, the research and the clear research and proven effectiveness of something like urea or superphosphate is there. With biofertilizers made from seaweed extracts, it's less clear. So there's still, and the understanding of the mechanisms of how it works is unclear as well. So we can have our seaweed fertilizers, biofertilizers, and they can be used in different ways. So with all of those different products, it could be used in for seed priming or for during the seedling stage for germination and early growth of seedlings. It can be applied onto soil as a sort of typical fertilizer, used in hydroponic systems with the liquid products. They go very well in hydroponic or aquaponic systems, or even through fertigation systems as well, where we've got irrigation with fertilizer put through the irrigation lines. Where some plants respond well to foliar sprays, they can be used like that as well. And also post-harvest, sometimes spraying to look at extending shelf life. So there's a whole range of different applications that are used and claims made about the effectiveness of them. As scientists, as plant and soil scientists, we want to know, well, what are the mechanisms? How can this seaweed work? And there's nutrient effects, so macros and micros. It could be a whole lot of really small compounds, so things like organic compounds or plant growth regulators, plant hormones, present in very small amounts, but have important physiological and biochemical activities, those sort of things, or carbohydrates in large amounts. Or it could be sort of indirect effects. It may be an effect. Does it change the soil chemistry, changing the cation exchange capacity, so holding on to nutrients, changing pH, which generally will change nutrient availability? Does it have indirect effects on soil physics, water holding capacity, improving that through somehow changing the structures, for example, the porosity or the drainage capacity? Particularly high carbon-based materials tend to have benefits for good soil physical properties. And importantly, in a very complex way, how do these things affect soil biology? So soil biology has a lot of functions in terms of decomposition of materials, of mineralization, of changing the soil environment, again, even looping back into changing the soil chemistry, maybe acidifying or alkalizing the soil. So there's a lot of functions, and how do these things affect the diversity? How do they affect the functioning or how the soil bugs achieve certain things? So that's a lot to look at, and I think there's really just not so much work on that sort of area so far. Yeah, and where does it affect the plant cycle? Some of the work that we've done is really just looking at basic growth. So not so much maybe early vigor and then growth, look at flowering and then fruit production, or we've done it with leafy crops as well, things like lettuces and Chinese greens or mustard greens. But also, and the other area that we've looked at is, do I talk about that? So and most of our focus has been on macronutrients. I guess they're the big things that, drive plant growth. I mean, all of those things are important one way or another. Plant growth regulators for making some of these transitions through the plant life cycle. But without macronutrients, plants generally don't grow very well. Some of these things may or may not be necessary, but macronutrients generally are. So that's what we're focused on. The other area too, I don't think we'll go through it today, but is stress tolerance. So just this morning I was reading about, I saw a paper on seaweeds and drought stress. Where were they from? That was an Italian research group looking at the benefit of putting seaweed fertilizers on, gave better resistance to drought stress. Some of the work I've done with another Australian student is looking at frost stress. So in Armidale, where I live, it gets -5 in the winter time, and we're trying to grow vegetables, and it's very difficult. So there's some evidence that these can help with frost stress, and also with pest and disease resistance, so building the strength of the plant. But most of the work we focused on is the macros. So is seaweed fertilizer on just a simple nutrient effect? Probably not, because generally low concentrations of macronutrients. So it's something other than that. There are reasonable concentrations of micronutrients because it's in the ocean and there's this sort of soup of micronutrients. They can have relatively high concentrations of microbes, but also they're pretty variable. In our research, when we've done locally produced materials, they're more variable, obviously, than when we buy a commercial product and try to use that. And here, don't need the detail here, but just you can see for 3 different extracts, so different red, green, brown seaweeds, and really different amounts of these elements. So here, this is red's low, this one's high, and so it just jumps around. So when we talk about a seaweed extract product, it'll really depend on, well, what was that seaweed, and also what was the extraction method. But you can see it really jumps around, and then you need to do we need to tailor our products to particular needs? Highly variable. So we with Pat Ramal and colleagues at UNTAD, we've done some trials looking at seaweed products and really wanting to compare the NPK, or nitrogen, phosphorus, potassium. So the key macros by adding. So we had our biofertilizer, and we worked out what's the concentration of NPK in those biofertilizers, and we mimicked that with just mineral fertilizers. And then we also took the seaweed products and ashed them, so burnt them down to just the ash, which is just the mineral ash. So got rid of all the carbon materials, and we could sort of think, all right, should be getting more or less the same dose of NPK through biofertilizer, through mineral fertilizer combination, or through the ash of the biofertilizer that's left. And so that's what we did. So comparing, we used 2 commercial products at different rates, the ashed, minerals only, and comparing it with mineral or synthetic fertilizer blend. And we tested that on 3 crops. Here we were sort of after a root crop, radish, a leaf crop, lettuce, and field peas, so a fruit type crop, botanical fruit, and all those different treatments. And here we found at the high rate, so basically we found that one fertilizer was better than the rest. So this maxi crop MC was better than sea salt. And again, I'd probably have to look at what were the seaweed varieties, why was that different? And obviously the high rate going from, so this is leaf dry weight in the lettuce, so it's gone up for 4, really high. But the thing that I think, and the control was low, but when we compared it with the NPK, this one, each time the high rate, or even these moderate rates, was better than just the NPK. It has the same amount of NPK, but it's got all those other organic and other compounds in there. And in each case, when we compare the NPK here, well, only the high rate, and the ash, so we presume that's the same amount of NPK, but through burning off the carbon. So they're the same every time. But so that was here we're getting it as well, but less clearly. So we've got the sea salt ash, sea salt NPK, they're the same. But when we have the sea salt 4, we've got a higher rate. The sea salt 1 was, actually the sea salt 1 would have had the same rate. That would have been the same rate there, so the ones. So there's something other than just the nutrient effect going on. So the ashed and the NPK are about the same and better than the control. So the one of the products, MaxiCrop, was effective, sea salt was marginal, and where there were effects, they seemed to be greater than just the ashed or NPK. Here we did it under water stress as well. So similar sort of thing, matched NPK, and just looking at interaction with water stress. I think this talk will be available if you really want to follow it up. I don't want to go through all that detail here of the methods, but it is there and published as well. Yeah, so here, when we do that, we did it with radish and peas, not with lettuce. And this time, so the seaweed was better than the control, but mainly the maxi crop, MC again. Seaweed was generally better than the NPK alone, similar or better, and seaweed was certainly better than the control for water stress. So we can see when there's dry, the brown ones are really the ones we want to look at. So having the maxi crop was better there for leaf dry weight, fruit dry weight, no differences for the peas, and only slight differences there. So in this case, the evidence for some benefit for water stress is probably quite weak, I would say. Slight benefit for water stress. That's not that strong. And the fertilizer effect was less clear than in the previous trial as well. So the work that I was looking at this morning, it sort of had clearer benefit of drought stress. It would depend on the crop. It would depend on how severe the drought treatment was imposed and so on. I think if it goes too far, then there's not much will help. All right, I think this is the last slide, or nearly the last slide. So really the conclusions, and I've basically put up the same slide that I started out with, that we still don't have a lot of information. We know that the challenges are there. We know that we need to use fertilizers and all agronomic inputs, water and crop protection as well. We need to be much more efficient in those for economic and environmental reasons. The conclusions here are still the same about that. Biofertilizers certainly have good potential. They're local and potentially cheap. They can help with soil, help with carbon, but they can be expensive and they're variable. You don't always know what you're getting in that bottle or in that bag from each point in time. What we have learned, just to finalise, is that that it's not just the NPK or a gross nutrient effect. When we have high amounts, we're getting good growth, but basically at similar amounts, then it's only a slight effect. So we want to look, and that's only for growth. We didn't really look at things like triggering of flowering. So looking at the role of plant growth regulators is important. Also looking at the indirect effects on soil, so the nutrient cycles, the biological activity. It may not be a direct effect. It may be actually, so not through NPK. It may actually just be making other elements more available or less available or changing pH and so on. So how does it affect the soil? Because generally these things are put in soil, not directly on the plant. More work on biotic stresses. So does it help when there's a disease? And so on. That's still very unknown. And abiotic stresses, such as what I've talked about, is drought and frost, but also heat stress, as we talked about with climate change and these extreme events potentially becoming more common. And once we sort of understand those, we can start to think about, well, not just optimizing application method, but also optimizing the production. So for a given seaweed variety, what's the best production method? And then what's the best application method and so on. So there's a whole lot. Actually, it's about production of the product as well. Or maybe I think I talked, and that's got socioeconomic and adoption implications. How reliable is it? Farmers don't want to spend money on things that may or may not work. And is it expensive? And probably the answer is reliability has question marks, and cost of supply may be high compared to mineral fertilizers. Quality control and manufacturing needs to be addressed to make reliability better and cost effective as well. So what's the minimal processing to still have a good agronomic outcome? Are there regulatory issues? Are there any pollution or other problems or human health issues? Should we not drink it or breathe it or something? So health and environmental regulation. Not sure what cost for farmers. So cost of supply. And then once we've sorted out those, how do we then get an extension program going to raise awareness and explain how to apply and how to what rates and so on, and how the benefits are. So there's still, I think, a lot of work, and I'm pleased that Pat Ramal is able to continue that work in Palu, and hopefully we can keep up conversations about that. So, yep, thanks to Ramal and colleagues, also to Dicty for various bits of funding over the last few years, and seaweed companies for supplying products, and my colleague, Dr. Nigel, and Techstar. Okay. Thanks very much.
Okay, thank you very much, Dr. Christiansen, for the very interesting topic delivered this morning related to the challenges for the agriculture and sustainability. I hope you still. Now we will move to the second speaker. After the three speakers deliver their topics, we will continue to the discussion part. So, ladies and gentlemen, now we move to the second speaker. I would like to know if Ibu Dr. Husnain from Indonesian Center for Agricultural Land Resource Research and Development already with us. Can you say hello? Hello, Ibu Husnain. Are you with us already? Okay. Before that, I would like to introduce Ibu Husnain.
Just unmute by operator.
Okay, thank you very much for joining us. Before you deliver your talk, I would like to introduce Ibu Husnain. Hello. We have a problem with the mic. Can you please give us another microphone for the committee? It's sometimes delay or not connected to the speaker. Okay, but it works now. Sorry for the technical issues in this conference. Okay, before we continue, I would like to introduce Ibu Dr. Husnain from Indonesian Center for Agricultural Land Resource Research and Development. She had a master's degree. She had a master's degree in soil science and ecology from graduate school Shimane University, Japan. She had a PhD degree in soil science, bioenvironmental science, Totori University, Japan in 2009. And from 2017 to 2019, she was the director of Indonesian Soil Research Institute, or we call it ISRI, Balai Penelitian Tanah. And from 2019 till present, she is the director of Indonesian Center for Agricultural Land Resource Research Development, or we call it BBSDLP in Indonesia. Today, she will talk about science data with title Food Security and Food Safety Against Climate Change in Indonesia's Perspective. So, Ibu Dr. Husnain, please have your time for 20 minutes.
Thank you for the nice introduction. I hope my voice is clear to all the audience. Good morning, ladies and gentlemen. It's an honor to be a speaker in this very important conference. As introduced, that I will talk about some scientist data, but I will talk more about the policy and the program to tackle climate change in Indonesia. Allow me to share my PowerPoint. Okay. Okay. So the food security and food safety against climate change, Indonesians' perspective. So I will talk briefly about the climate change, impact, goals of agriculture sectors, and also at the end is a conclusion. So we know that the climate change is not happen only today. The climate change is happened since a long time ago and still going on until today. So why? Because we are living with the live Earth. We are living with the carbon. We use the carbon. We release carbon, and we are also made from carbon. So according to the projected data, the rainy season will reduce by 10 to 20 days, even more in some areas. So this will affecting the planting season and also other things related to agriculture. The agricultural sectors is very vulnerable to the climate change. We know that, we realize that. So it's become a victim in some side, in one side, and it's also able to reduce the greenhouse emission in another side by taking a carbon from the air and also by different processes. So this is a greenhouse gas emission source from agricultural sector. This is only the main main contributor from the agricultural sector. There are other sector also contribute to the greenhouse gas emission. And let's we see that methane from the rice field, usually it's count as the highest greenhouse gas emission sources. Nitrous oxide from nitrogen fertilizer, methane, and also nitrogen oxide from the animal manure, and from enteric fermentation from the animal burping. So now I will bring you to the policy on the climate change in Indonesia. In this slide, it shows that NDC of Indonesia. The NDC means a national determined contribution. So we are talking about NDC of Indonesia. Each country has its NDC. So the agricultural sectors nationally only contribute about 8% of greenhouse gas emission, only 8% in total compared than other sectors. So there are two important points in this table, as you see. One is the CM1. It's a complicated table, I realize that, but let's see what is the CM1 and a CM2 and also BAU. BAU is business as usual. CM1 means climate change action without intervention. So no funding from outside Indonesia, from other country. CM2 means the contribution from the international funding or other support. And BAU as a business as usual. So in 2010, look at this column, the level of greenhouse gas emission of agricultural sector in Indonesia is about 111 million ton CO2 equivalent. And target emission in 2030 is 102, in the next column, 102 million tons CO2 equivalent in the business as usual. See this 120. So 110 is the greenhouse gas emission level in 2030 with the CM1, with the all source from Indonesia, and it's 116 with the CM2 with all the support from the outside Indonesia. And in the next column, greenhouse gas emission reduction. Let's see the reduction in the CM1. Let's just go to the presentation of the total BAU. In CM1, we found it 0.32% percentage of greenhouse gas emission reduction of total business as usual with CM1, and 0.13% with CMU. It means with the other support, other country support, other funding. So this is a little bit a question maybe. rising big from this data. Why with the other source funding, its greenhouse gas emission level increase and the percent of reduction is decreased, is lower than CM1. It's because the reason said because once we get funding and the development of agricultural infrastructure is increasing, this means the carbon gas emission also increased and other gas emission, including nitrogen emission. But with this additional support from other country, we can improve the agricultural production, agricultural sustainability, and other things. So at the end, we hope that decreasing of the CO2 and other greenhouse gas emission will reach the target. But actually, as we count, as we estimate, until 2030, we already got 110 in CM1. So we don't have more effort, large effort, a strong effort anymore to reach the NDC target of NDC of Indonesia. So this is led by a Ministry of the Forestry and Environment as a focal point of the climate change in Indonesia. So all sectors have to report the greenhouse gas emission in each sector, including us. We have to report agricultural sector contribute to the greenhouse gas emission. So next, to reach our target, as explained in the table before, in the before slide, the Ministry of Agriculture, they're planning some strategic program as written here. There are three main program to tackle with climate change. The first is optimization of the smallholder oil palm plantation. For example, through the replanting the oil palm, there are some targets here. We should be coordinating with all the stakeholders to reach this target of the planting. And the second is rehabilitation of abandoned land through planting trees with the high carbon stocks. The target is about almost 1 million hectares of abandoned land can be replanting before 2030. It is the target. The third is the rehabilitation of the pastures in West Nusa Tenggara and East Nusa Tenggara by planting tree legumes. This is to get the carbon in the legume plant. So the target is about 140,000 hectares before 2030. So actually, this is what we simulate, what we estimate. The three main programs, except the regular program from the Ministry of Agriculture and also the government of each province in Indonesia. So this is the additional program to reach our target. So according to the national agency of the planning, or Bappenas, they calculate the potential economic loss due to climate change is about 544 trillion rupiah if no policy intervention. So if it's a BAU, business as usual, we are doing nothing, we will lose such a big amount. So we have to consider, we have to support all the program from the Bappenas, who already set up the program to how to handle our impact of the climate change in all the country. So in agricultural sectors, the main goals of our development is first, improving food security and sovereignty, increase the added value and competitiveness of agricultural products. The third is increasing the supply of bio industry and bioenergy raw materials and increase farmers' income and welfare. This is the main important program to adapt to mitigate and adaptation with the impact of the climate change. And we have also follow the goal 2 from the SDG for the zero hunger, goal 2 in the zero hunger. So there are some action we can help for this. We have to guarantee the fulfillment of basic food needs for low-income household and disaster-affected community. Provision of staple food, especially local food from domestic production, increasing productivity, protection of cropland, improvement of land and water quality, development of environmentally friendly cultivation, as like improving the quality of food and nutrition consumption, and also safety, promotion or campaign of healthy diets, provision of food security in infrastructure. Food security early warning system is also important. It will improve the efficiency of the information system and disaster management related to food and nutrition, developing social institution. I have some slide here to show you what we are doing and what we are already count and estimate for the climate change action, national climate change action. There are some groups here. The one is the providing water reservoir for irrigation by construction of dams, ponds, and detention pond for agricultural irrigation, rainwater harvesting, and rehabilitation of dam or reservoir. And second is providing irrigation canal systems by construction of the tertiary irrigation. Is the Ministry of Agriculture responsible for this tertiary irrigation facility, a new construction or modification of irrigation system, and rehabilitation and maintenance of irrigation networks. This is also still, we have the problem, we are facing the problem with the irrigation network. And application technology of information system, we built a cropping calendar of rice cultivation. Maybe some of you already familiar with this cropping calendar. Because due to the climate change, the planting season will change by the time, and we need a cropping calendar to suit our target productivity target. The fourth is providing barrier for flood by restoration and construction of boulders in paddy field, and also a construction of river embankment around agriculture to prevent flooding. And providing an adaptive farming facility. There are many things we have to provide. We have to supervise, for example, superior plant seeds, the high yielding variety, providing organic fertilizers, providing pest and disease controller, and modern agricultural tools, or the smart farming or precision farming or whatever we call it. And agricultural land expansion. We need expansion to the new field. Of course, the remain land is unproductive land or our marginal land. So you see here, there are some picture already promote to adopt with the climate change. For example, providing water reservoir irrigation. There are some technology, we call it embung using geomembrane, and water harvesting, and providing irrigation canal, as in this picture. Ministry of Agriculture already constructs some facility like this in some area. And this is a cropping calendar. We call it Kalender Tanam Terpadu in Indonesian. We released the new version already, and this is several adaptation activity yang which give co-benefit as mitigation. So in our term, the mitigation of the climate change, or mitigation of the greenhouse gas emission, we modify into adaptation and mitigation of the climate change. So we use adaptation technology, and it's also co-benefit as a mitigation of greenhouse gas emission. So we are using both, not only mitigation. To alternate wetting and drying, AWD, we already know that this is the best technology, but it's not easy to adopt by farmers. And balancing fertilizers, we are always promote a balanced fertilizer, and multi-strata agriculture by promote how to taking the CO2 sequestration more and more, and improving of coal feed quality by improving body weight growth and population, and decreasing the drainage depth of peatland. There are some new rice variety developed to adapt with the climate change. There are many variety as listed here. In 2021, we have a very new high variety, like in Pari, Ciherang, Mekonga, also, and other in Pari type. This is a new rice cultivar for facing climate change. We have to promote this new variety for whole area of Indonesia. For example, the early harvested period, so the short period of the rice, we have in Pari 13 and 19, Takrabuana and Pajajaran, with also high yield potential. And the variety tolerant with acidic soil, like in Pago, 6, 7 until 13, Rindang 1 and Rindang 2, and the new variety with submerged tolerance in Pari 30 and others, salinity tolerance, brown plant hopper tolerance, also bacterial leaf blight tolerance, and blast disease tolerance, and also tumor disease tolerance. So we have a lot of option to adopt with our climate change. And this is a superior trait rice cultivars that efficient input and resistant on pest and disease. So I think this is all already on the list before. I will move to fertilizer. So we also provide the recommendation for specific location for mostly strategic commodity. For the 11 commodity, we already provide this recommendation. We distribute to the head of the agriculture office official in each province and also each regency. And alternate wetting and drying. This is only more clear by the picture. And soil conservation also. We need to do soil conservation like mechanical technique, vegetative technique, and also chemical technique to control erosion and runoff. And this is also a kind of co-benefit on mitigation. This is how we made a bangku terrace, and using the rock, and also in some area in Indonesia, it really works. And this is an example of the vegetative soil conservation technique with a terrace strip, crop residue line, legume cover crop, mixed farming, and also using mulch. And this is actually the only main program. We estimate the greenhouse gas emission of Indonesia through this important program. Because we believe that so many programs also in our others ministry are related with the agriculture, also has such program to support the agriculture, but we have difficulty in the counting. We have difficulty on the tracing the how they doing the program, and the budget on that, and also the result of the program. So we, for now, only this program, we calculate the greenhouse gas emission. Maybe in future, we will add more with, for example, the oil palm industry and others, plantation industry. So from biogas, we found this is emission. From the UPO is a unit of the to produce organic fertilizer, and from organic village also, low emission rice variety is the highest emission greenhouse gas emission. reduction, and enhance the feed, balance fertilizer, and also water table management on peatland. So we are still working on the how we calculate, how we estimate our greenhouse gas emission. So the closing, the climate change is increasingly having an impact on all sectors of life, including the agricultural sector. The real action and strategies are needed to deal with the threat of climate change in the agricultural sector to maintain food self-sufficiency. Technological innovation to deal with the threat of climate change impact already invented, for example, new rice variety or decision support system on some area, including rice field, water management technology. So Indonesia has developed a strategy to deal with the impact of climate change through the application of technological innovation. Professor Paul in the previous presentation already give us so many information that was possible, that potential for us to develop. So we can adopt more innovation technology to tackle with our climate change impact. However, the real effort is really needed for all related parties in tackling the impact of climate change. So that's all my presentation. We can have a more discussion later. Thank you very much.
Thank you very much, Bu Husnain, for the related to the food security and food safety against climate change in Indonesian perspective. I keep my eyes on the screen to see all of the data you present, all talk about very new information related to the topic that we discussed today. And therefore, we thank you very much for that. Ladies and gentlemen, now we move to the last speaker for the first session. It will be delivered by Ibu Dr. Ayan Choa from Faculty of Agriculture, Tadulako University. But before that, again, I would like to introduce her. She had her Master Science from Copenhagen University in Denmark and her PhD degree from Hohenheim University in Germany. For the professional organization, she is belong to the Indonesian Young Academy. Hello. She is belong to the Indonesia Young Academy, or we call it Akademi Ilmuwan Muda Indonesia. She is also a member of APIC Indonesia, or Network for Experts in Climate Change and Forestry in Indonesia, or we call it Jaringan Ahli Perubahan Iklim dan Kehutanan Indonesia. Currently, she is also General Secretary of Forum of Associate Researchers, Foreign Researchers in Indonesia, and also speaker for BPDKS, or Badan Pengelola Dana Perkebunan Kelapa Sawit, and many paper has been published by Ibu Ayan as first author and co-author, and she will talk about environmental factors in Indonesia oil palm with social economic benefit. Is it conflicting goals? Please have your time, Bu Ayan. So maybe you can use this one.
Thank you, moderators. Very good morning to the audience that attended online and offline. As mentioned, my name is Ayan Chua. I come from the Tadulako University, in particular, precisely from the agriculture faculty. I would like to thank my deans is here, and vice deans, and our valuable guests from different universities, and also my colleagues, and also all the participants, valuable participants of the conference. both presenters had been deliver a very nice presentations, and luckily I picked up something quite different from the first and the second presentations. Otherwise, this will be very, very close to the two others. So I'm very lucky. So I would like the presentation of today entitled Environmental Factors in Indonesian Oil Palm with Socio-Economic Benefit. Is it conflicting goals? We know that Indonesian is the first producers of oil palm, and they are creating a lot of issues and also global attention. So it might be a good opportunity today when we are talking about sustainability, whether sustainability can be achieved. We can take a look on the oil palm production in Indonesia. I hope the voice is clear.
Yeah.
Okay. Indonesians is the major oil palm productions, so there are several vegetable oil worldwide. The oil palm are occupy around, sorry, I look at on the pointer. Okay, with the laser pointer. So in the last 10 years, between 2012 until the 2022, that the oil palm produced by the oil palm country is increasing a kinds of nearly 40%. And Indonesians are as a major productions are produced around 60% of the oil palm need by the whole world. Yeah, so increasing of vegetable oil production, in particular for palm oil, soybean, and sunflower, will still continue. So it's expecting will be continue, and 16.38 million hectares of the oil palm are in Indonesia. Oil palm is one of the highest efficiency of oil production. So even people like it or not, but oil palm is very effective. So when we would like to produce other crops to gain oil, when we compare between the rape or mustard compared to oil palm, we only need 0.4 hectares of land to produce the similar amount of oil from the rape. So when rape is 1.5 hectares, we only need oil palm 0.4 hectares. So area needed to produce the same amount of palm oil by sunflower rape is about 3 to 4 times larger than the oil palm. It means that when we have to convert land use change will be more drastically changed when we produce rape or soybean as oil. Yeah? And land use change, one of the major problems of agriculture is impacted to the land use change. In Sumatra region, rubber and oil palm were grown since the colonial time, since the colonial rule in Sumatra. When we look at on the map that published by Lumiere, in the year of 2000, that the area which was covered by natural forest in 1985, was mostly removed
Excuse me, maybe
because
we have
of plantations.
To pause a little bit. There is a technical issues in the presentation.
The online?
Okay, it's working now. Thank you.
Okay. So you could not see the screen?
Okay, it's already working.
Okay. Yeah, so this was the slide that explaining the high efficiency of oil palm when we compare between oil palm with others vegetable oils. So oil palm is one of the very efficient, and as we all know that productions, or talking about production of oil from the vegetables, they are very often linked to the land use change. So land use change, or LUC, is one of the hot topic. Yeah. And when we look at on the map on the right hand, that the changing is quite dramatically in 15 years, that we are losing a lot of natural forests in Sumatra, in particular, the major area of the oil palm. Riau, as alone, as one province alone, produce or having nearly 4 million hectares, so 28% of Indonesian oil produce, palm oil produce is by the Riau province. So we established one of the collaborative research centers known as Ecological and Socio-Economic Functions of Tropical Lowland Rainforest Transformation. And this consortium consists of Tadulako University, Jambi, IPB, and working together with our partner University of Göttingen. And the research are funded by the DFG, the Deutsche Forschungsgemeinschaft, or known as the German Research Foundations. And the location of the research is in Jambi province. And we are starting the research since the year of 2012. So this project is long-lasting, it's for 12 years. And the overall goal of our research project is to establish knowledge on ecological and socio-economic functions and trade-off in the tropical lowlands in order to protect and enhance ecological function and the human welfare. With another word, we are trying to reconciling conservation and the human needs. Our subgroup in the project consists of 3 major subgroups. The A group are working on environmental topics, and the C group are working on human dimension, or working on or doing research on social economics, and the B groups are mostly working on the biota and ecosystem services. So we are having a very huge research group, and we successfully carry out the first phase of the sub-project, the first phase of the CRC and the second phase of the CRC. So in each of the phase of the project, we have a kinds of 25, 27, even until 30 subtitle of the project. So means that in each of the project, we have many PhD students and postdoctoral as well. So in 2 terms, in 8 years, there were 58 PhD completed from our project, 50% Indonesia and 50% from the German sites, and we have also a kinds of 55 master students are completed from our project only in 8 years. So we are one of the most successful projects in Indonesia. And the research designs, unlike many other projects, we are doing research on a permanent plot. So we are established 130 plots in Jambi province, and those plots are staying for 12 years. So a long-lasting experiment, so a recurring experiments from year to years. And we also having, for social economic data, we collected from 170 village. Yeah, so 170 villages also for 12 years long. So all data are comparable. We have control plot in forest, tropical rainforest. We have rubber agroforestry plots. We also have rubber plantation, which is monoculture rubbers, oil palm plantation, and also shrublands. So those plots are for comparisons of the environmental effects, and the villages are for comparisons of the social economic for the research. I would like to show here about the carbon store, so that one of the major findings, and I think which is people very interested on when you are working on oil palm, is how much carbon loss when you establish, convert a land from forest to oil palm. So we published there's a significantly loss, of course, of carbons, yeah, from the rainforest, which is that calculated as 284 megagram carbon per hectares, that we are losing about 61% when we convert it to oil palm. But question is, in the forest, you have a stable condition. Yeah, so no removal of biomass out of the forest area. However, in the oil palm, we are regularly harvest, so we remove yield from the side. Yeah, so I would like to attempt here that we could not compare directly, yeah, carbon stock loss from a forest with an agriculture, this is a very interesting point by many international researchers that to attempt it that the lossing of carbon is very strongly when we convert it to oil palm. It is correct, of course. Our research also show the same, that lossing carbon is significant. However, what we did not have from a forest is the removal of biomass, but in the oil palm plantation as well as in the rubber, we remove yield from time to time, which means when we calculated the yield, yeah, and the carbon stock left might be equal by the end. Yeah. Next slide, that this is not particular for oil palm. In fact, all other plants are play the same problems, in fact. Yeah. But for oil palm, land use changing leads to surface warming, which is we don't want, which is we create emissions. So the forest as a reference, let's say so, for measurements, when we have measured oil palm, the surface warming, the Celsius is above nearly 1 Celsius only. But when we have a very young plants in the field, the surface warming is achieved 6 Celsius. But this is not particular for oil palm, for many others plant. This would like to say, this slide, that covering crop on a bare soil is very important to reduce the warming of the surface of the land. Yeah, when bare soils, that you will have more or less 11 Celsius. Yeah, so which is merely very will play negative on the emissions. And when the question is, when we have oil palm in one cycle of life, 25 years or 30 years, whether the global warming, yeah, the GWP, the global warming potential is a stop or is a sink. And our research clearly show we have problem in the first generations of the oil palm. Oil palm in the first generation are still playing as a carbon stocks. That's why we are very often defended to the Europeans regarding the productions or the export of the Indonesian oil palm. Yeah, so this cannot be eliminated, that we still have problems, that in the oil palm of the first generations, that we still having a positive global warming potential. However, when we could increase the life cycle of the oil palm from 25 years, 30 years, even to 40 years, when we achieve 35 years old oil palm with active production, then the GWP are lower or even zero. So we believe very much that the second generation of oil palms are more green, let's say so. Yeah, so green product, because we at that time and at the second generation, the oil palm is not an emitter. Yeah, so, but we have a problem on the first generation. However, this is also a good sign for research that to challenge everybody who working, for instance, on seedling, that how we improve the oil palm, yeah, so high yield, long life, 40 years, yeah, so this, I think, the possibility is very high, yeah, so there's a challenge for everybody to do research on that. And when you saw on the left, that you see a tower here in oil palm. This is our research area. We are measuring with Ecology. We have a tower, climate tower, 23 nearly 24 meters, so higher than the canopy of the oil palm. And this is located in the PTPN 6 of Batanghari in the Jambi area. So we invested millions, nearly 20 billions, 20 miliar, yeah, to build the climate tower to measure the fluxes of the oil palm for long term. Yeah, so land use affects key ecosystem variable. We are losing tree biomass, 80%, carbon stock, 61%, canopy height is also reduced when we change from forest to plantations. Canopy cover as well is reduced, carbon resident time is also reduced, understory plant density increased, but the understory plant height is reduced. Question is how that we overcome those key ecosystem variable when we change the land use. So this is a challenge for research. And then one of the major topic when talking about oil palm, of course, biodiversity. Affected biodiversity by the existence of the oil palm. Yeah, so a negative campaign is very often done, yeah, very often done by the international party to against the Indonesian oil palm is on the biodiversity topic. But whether this is a kind of black campaign or this is a true campaign or whatever, but the fact is there is a decreasing of biodiversity when we convert. But the conversion from forest not be necessary to oil palm only. So all major other crops we will lose biodiversity when we look at on the land use change. However, because Indonesia is the major productions, yeah, the major producers of the oil palm, of course this is of the international interest to look out on the biodiversity. And the challenge is just like the conference title, is there any possibility to enhance or to protect the sustainability in agriculture, not necessarily on the oil palm only. But of course this is became our major task for oil palm because Indonesia contributes 60% of the oil, palm oil in the world. When we look at the graph, it's very interesting. We are studying on the 14 group of taxonomies. Yeah, then we saw that we published, of course, that the forest specialist species, yeah, from these 14 taxonomist groups, there are some specialists only present only in the forest, but some generalist species are present in agricultural land and other land uses. And there is agriculture specialists, so that the biodiversity that only exists in agriculture, not exists in forest. Yeah. So the question is, when we losing our biodiversity, spatial diversity in the forest, what is the linkage with the agriculture? Because the agriculture land also have their own specialists. Yeah, and this is actually a very interesting for people who studying about ecosystem services. And this is very new, and not many are doing research linkage between the loss of biodiversity in the forest and the biodiversity itself in the agriculture land. So agriculture area also have their own specialists. Yeah, so the question is, what are the consequences? Yeah, so talking losses is very easy. Yeah, going to the field and doing research, we lost this, we lost that. Yeah, but the question is the consequences that we lost in the forest, but we gain something in the agriculture, and what is the consequences for the ecosystem itself and for the services, and strong losses in the local species diversity. So when we compare between forest, jungle rubber, and oil palm, of course, the multi-diversity is losing. Yeah, so this is our concern. Yeah, when losing multi-diversity, what is the consequences later on for the agriculture productions? We also, in our group, is also working on more simple things. Yeah, so we established 16 plots. One plot is a half hectare, so a very huge plot. We have 16 plots. It's a block designs. Yeah, 2 treatment. Yeah, fertilizers, conventional treatment, and the reduced treatments. Reduced treatment is calculated from the yield that removed from the field. Yeah, so very low compared to the practice. The conventional fertilizer treatments are very likely the similar amount that used by many companies. Yeah, so 260 kilogram nitrogen per year in the conventional plots, and only 136 kilogram of nitrogen in the reduced treatments, and we combine with weeding treatment, weeding with herbicide and weeding without herbicides. Yeah, mechanical weeding. So it's a factorial experiments. Yeah, so two factors in block designs. Yeah, what we achieve, higher biodiversity with the mechanical weeding. So the non-herbicides are having more biodiversity, and lower biodiversity with herbicide. I think it's not surprising. But what surprise is lower input. Yeah, so we are using reduced fertilizers, very low input. Even after 6 years of treatment, yeah, lower input without compromise the yield and the profit. So we're still having a very high yield and profit after 6 years of treatment. Yeah, so this is clearly to show that we actually can maintain better profit, at the same time prevent the loss of the biodiversity, and at the same time that we still having high yield. So this is a very possible. Also, we measure the nutrient leaching. So lower fertilizers will impact on lower nutrient leaching, of course, in particular for nitrogen. So it's very interesting in the conventional management that we lost 8%, but in the reduced management, we also lost 28%, similar percentage, but different amount, of course, because in the conventional, we apply 260 kilogram of nitrogen, and in the reduced management, we only apply 136 or 130 kilogram nitrogen. Lower nutrient input will in fact bring lower leaching, but yield are not lost. So we are not losing any yield. So this is more friendly, maintaining the sustainable on the oil palm productions. And we also having another experiments, huge experiments on enriching. So we having 52 plots that we enrich oil palm with other trees. So from durian until petai. Yeah, so we introduce native tree into the oil palm plantations to see how the successions of the biodiversity, how the biodiversity are came back, yeah, to the area. But at the same time, it's also to measure whether we lost yield when we combine with other trees. Interestingly, on our research, yeah, enriching oil palm plantation with native trees, we still maintain a very high yield, not losing any yield. Yeah, but at the same time, you see the picture is very nice. So you have the oil palm, but you also have another canopy, other trees. Yeah, so more organisms benefit from the tree enrichment without comprising yield. So yield are stay as high as the plots without any introduced trees. We also later on measures when enriched tree to the oil palm is very important, but how this method be adopted by the farmers, how farmers would like adopt the result of the research. And this is also published by Romero in our group, our PhD students, so that we give the farmers trees. So we put farmers in different groups. Some group is only give them information. Some of the group we give information and seedling, and some of them we only give seedling. So how the farmers are adopted our research. Yeah, whether the farmers would like to introduce tree into the oil palm. And we see that when we only give information, only 6% of the farmers implemented tree in the oil palm. But when so we give both information and seedling, and the farmers are adopted our methodology significantly. 38% of our farmers are taking around. Since the title of the presentation is whether there is a conflicting goal when we are losing negatively impact on environmental, and on the other side we also gain economic benefit, whether this is conflicting goals. In our research we saw that for the social economic, which is this cannot be negligible, oil palm are play a significant role to improve livelihood. Yeah, so strongly impact on the local economy, also national economy. So poverty in the different types of village in Jambi province, yeah, village with oil palm is usually wealthy, yeah, wealthier than many other villages without oil palm. So when we compare oil palm villages, yeah, there are less poor people. Yeah, so wealthier. Yeah, so household incomes are increasing at least 13%. Consumption and the nutrition of oil palm villages are much better than the non-oil palm. They're also having better roads, better electricity, so better infrastructure. So oil palm play major roles in economic, but also the first effects on livelihood. We also see that with oil palm, women actually benefit because you don't need to work harder compared to when you have rubber plantations. In rubber plantation, the share of female laborers are higher than the farmer than in the oil palm plantations. Means that women have minimal labor input in oil palm. At the same time, women spend more time with the household chores. Means that we are expecting a better quality family from an oil palm family. So others adverse effect can be unequal access to benefit and resources in socio-economic, local conflict, in particular about land rights, and reduced ecosystem services, for instance, water and pollinators. So when we are talking, so this is nearly at the end of my presentations, exploring option of restoring biodiversity and ecosystem functions. When we see this graph, that biodiversity ecosystem function is going down, but at the same time, economic functions is usually increasing. Yeah, question is, yeah, land use intensity. The question is where we are. We would like to have this graph, yeah, the red one, biodiversity ecosystem function is reducing with increasing of land intensity. Yeah, at the same time, we have better economic situations with the change of the land use intensity. Yeah, to balance these two graphs, certainly need strong research and understanding. So restoration is one of the measures. That's why the UN decade between, yeah, so one decade, 10 years, 2021 to 2030 is about ecosystem restoration. That is mean that we have to restore between the biodiversity decreasing, at the same time we have economic benefit, but where is the line of enough? Enough, where is the line? Yeah, so we have to perform more research, but on the other hand, also a better education to everybody, to the young students. Outlook, the last slide of me. Yeah. So these two balance between environmental factors and social economic will no ending, will never end. Yeah. So never ending. So environmental and social goals may be in conflict. Who benefits and who suffers? Yeah, this is an open discussion always. The environment provides resources to economy, but act as a sink for emission has been also presented by Bu Husnain, yeah, and cost degradations. So the question is, what we are looking for, a net benefit or a net cost for society? Yeah, how the environmental policies can help to make the most out of environmental protections and economic growth, and holistic approach to analyzing and addressing problems and reform shall be adopted. So this last slide are very much in the directions of the presentation of Bu Husnanian. So thank you very much for your attention. I hope that you be with my lecture, that you gain something and can continue with the research. So thank you so much and have a fruitful discussions.
Well, thank you very much, Ibu Dr. Ayan, for the very full of information topic related to environmental factors in Indonesian oil palm with social economic benefit. Is it conflicting goal? So you just presented to us how the scientists argue that oil palm actually only making a problem in the world, but you already show us how the balance is appear actually by managing the landscape. And we a little bit late to the lunch break, but before that actually we will have a discussion session, and some of you maybe already see the question in the chat box of Zoom. And I would like also to thank to Dr. Paul Christiansen. You already make a direct discussion with the some question in the Zoom chat box already. But here, I would like to show you some questions already asked by the audience in online participants. For example, question from Pak Darwis asking about which one is more profitable for fishermen to make fertilizer or sell directly, and Ibu Yani Taufik asking about the case from Southeast Sulawesi where nickel mining is very massive and it may be a problem for the agrarian chain transition to be unavoidable. How, in your opinion, the from of agriculture change, especially food crops in the middle of the dynamics? And still question also, oh no, this is already a direct answer from Dr. Paul Christiansen. And question delivered to Dr. Husnain. I ever hear that there are several plants that is able to reduce CH4 emission. Do you think it works well? From Ibu Rizka. And another question, many efforts have been done to reduce greenhouse gas emission from agriculture sectors, especially in paddy rice. Where are examples on efforts that have been done in horticulture sector? Question from Pak Komang Damarjaya, Pak Ikomang Damarjaya. And another question also for Ibu Dr. Husnain. One of the efforts to reduce the impact of climate change is by using the new rice cultivars for facing climate change as previously presented, such as in Pari 19. Cakrabuana in Paris 30, and etc. How do farmers get the above cultivars? Thank you. Question from Ibu Nugrahaini. And question delivered to Ibu Dr. Ayan Choa. What are prospects for the developing oil palm in Indonesia in relation to clearing of oil palm land and the decline in the value of biodiversity and its relationship to carbon stocks? So I may ask you to answer the question not more than 5 minutes to all of the speakers, and I would like to start from Dr. Christiansen. Do you hear the question already? Hello, Dr. Christiansen. Do you still with us?
Yes.
Okay, great. Do you already get the question, right? So please give an answer and continue with the maybe closing statement from your side. No more than 5 minutes, please. Please.
Okay. Do you mean for the questions that were put to me or to everyone? These ones. So yeah, I think. So thank you, Darwis, for sort of talking about the economics. I think that is really important. What I'd like to do, really, and something I probably need to talk to colleagues at UNTAD, is looking at the whole value chain for seaweed, for the seaweed products, and looking at the different pathways and the profitability and the opportunities to take advantage of things. So I'm not aware of any work that's been done on the economics of it. So I think it's a big open question, and certainly that's your point, as you've said there, because the economics is number one in the end, and so it is very important. But I think having a sort of a scientific proof of concept is important as a first step, and I think we've sort of started to do that. So I'd want to be talking to Ramal and colleagues about how we could look at adoption and the impacts of adoption and so on. So I think it's a good question, a good idea. It's that I'd like to follow up, actually. So thank you for alerting me to that. For the other question, was it Buyani? Yeah, and when I read that question, it made me think of the time I've spent in Jambi province, and so it was interesting for Buyayan's talk, because it was sort of quite, some of those areas were quite familiar, Batanghari and places like that. And seeing those really intense land use pressures, the pressures around addressing poverty, desperate need to make money, which can often lead to poor governance, but poor land use and so on. So I think that's I've seen that pressure in Jambi, having travelled from Padang over Kerinci and down to Kota Jambi. I think the issue around migration, because often I think with agriculture, and that was part of my reply, we can develop technologies and all sorts of things, but my question often is, who will we, when we talk about farmers, who will we be talking to in 5 years' time? With the population is ageing, as you say, there's so much urban migration, people are moving away from rural areas. There's labour issues, accessing labour, so solutions have to be low labour. And so that whole sort of demographic change is really important, and I think that's why I made that point. I think it's happening much more quickly and probably more intense than climate change. Everything's a challenge, but I sort of see the changing in who's in rural areas and how will they adopt. One thing that we've seen in Australia is moving away from government, the government's role in agricultural extension to private role. So we almost don't have government extension staff anymore. And probably there's very few. And so if a farmer needs help, they go to a commercial provider, a commercial animal health person, commercial plant health person. So sort of that whole question about the farmer, who will be farming in 5 years' time, but who will be providing services as well, are really important, complex questions that I think things are changing quickly, and I think researchers are not always, right up with the latest situation. So I don't have any big answers because they're complex problems about land use conflict and poor land use. Like I said, I think you've got to have regulations, you've got to have, and you've got to enforce those regulations. You've got to have policies to try to drive in a positive way, drive change in a positive way, and so on. So I think it is complex, and seeing, as I said, that those real challenges in Jambi province, and also seeing the role too of so I visited oil palm and rubber farm over there, and seeing the potentially good role for smallholders as well. When I went to Jambi the first time, I was interested in organic vegetables. And I quickly sort of thought, no, not organic vegetables. There's so much labour. It's so hard to get it to market, so hard to get a reliable income. For a smallholder, doing oil palm is maybe much less risk, much less labour, and so on. So, you've got to change your ideas. Is that all? Did you want me to continue about something else, or?
Okay. Thank you very much, Dr. Christiansen, for the very complete explanation related to the question. Okay, now we move to the second part for the Q&A discussion session. The questions are delivered to Ibu Dr. Husnain. You may already know the question, or do you get already the question, Ibu Husnain? Are you still with us?
Yes.
Okay, good. Please have your time also together with the closing statement from your side. Thank you. Please.
Okay, thank you, Pak Darwis. Let me try to respond the three questions. Number one, actually, yes, this is debatable, I'm personally also have the same question with Burista, but the research of this new variety show the trend of that. So far we use that result. For example, the rice cultivar, there has a small emission compared to other cultivars due to the less number of tillers. And you know that methane from rice paddy come out through the aeration, what we call that. So the less number of tillers will contribute to less methane. So far, that's the research we have done by our friend in the Environment Research Institute in Balingtan, in Pati, Central Java. So we can also explore this methane reduction from the new rice variety through the collaboration with the university in the future. I move to the second question. For the horticulture, of course, all the main program that we estimate the greenhouse gas emission are also adopted for the horticulture sector. And for example, we plant the annual plant like fruits plant, mangoes, guava, durian. It will contribute to increase the carbon stock, of course. Other than that, good management practices, good agricultural practices also will reduce the greenhouse gas emission. And mainly the fertilizer balancing and how to apply the fertilizers, deep or pocket of fertilizer application will reduce N2O emission. And I think I hope I answer your one and two question. The last question is actually all the new rice variety, almost 96% of the rice variety in Indonesia are coming from the Ministry of Agriculture, from what we call the Rice Research Institute in Subang, West Java, Indonesia. And basically, all the new rice variety are available in BB Padi, but we have BPTP, what we call that. Now we call it BSIP Sulawesi Tengah. Bapak Dr. Abdul Wahab is with you today. He's present offline in the meeting room. Dr. Abdul Wahab is the head of the BSIP Sulawesi Tengah, and he has a UPBS, what we call UPBS, unit for distributing rice seed for farmers. So you may contact him, Dr. Abdul Wahab. You are there, right? So you can contact them and ask how to get the seed. Actually, we have a different type of seed. There is parent seed stocks, and also what we call ES. ES is what available in the PTP. So we can use it and planting by farmer, and again, they distribute to other farmer. So this is the way Ministry of Agriculture disseminate their technology through the new rice variety. And I'm really appreciate the presentation from the Professor Paul and Ibu Ain. Is very, very sophisticated, and I'm happy with this result. Later, we may collaborate especially on the seaweed fertilizer potential, and also Bu Ain with the oil palm measurement in terms of the greenhouse gas emission. Thank you very much, and really happy to have all of you in this conference. Thank you.
Thank you, Bu Husnain, for answering the question from the participant. Ladies and gentlemen, now we move to the last question delivered to Ibu Dr. Ayan Choa. So the first question asking about the prospect for developing oil palm in Indonesia related to biodiversity. And the second question asking about if we use other plant or vegetation to increase ecological services, for example, using refugia, do we still need to fertilize the refugia plants? Thank you. So please have your time for answering.
Thank you, moderators. Thank you, Pak Dr. Edi. And I'm very pleased actually today that also to get know Professor Paul as well as Bu Husnain. So I think there will be a good chance for collaboration in the future for more things. In the CRC project, in the CRC 990, also well known as EFORT project, that we receive a kind of 180 billions, 180 miliar per 4 tahun, ya, so 180 billions Indonesian rupiah for 4 years research. So a very huge research where I sitting as the coordinator of this research. So I'm managing all the research as well as playing as a researcher in that project. I always say that from these 12 years of research in the Jambi area, that the prospect of the developing of oil palm in Indonesia are still very huge. And when we see or when we goes back to humans growing population, so that we are growing a kind of will be nearly 9.1 millions people, yeah, in 2050, and Indonesian might achieve 330 millions till 2050. So the need of oils for food, for cosmetic, and for biodiesel are still been increasing. And oil palm is one of the very promising because of the very effective of oil productions. But as mentioned in my presentation, and I think most of the participants also know that we are facing challenging on the huge landscape of oil palm in Indonesia, landscape scale. Yeah, there's play some dangerous on the environmental effects. Yeah, because with such a huge landscape of oil palm monoculture, that we might reduce pollinators. Yeah, so this we cannot cover our eyes that we facing problems. However, research is also very front. Yeah, Indonesian is also making a lot of achievement from policies, also from science achievement. So I still believe that with the Indonesians nowadays, science development, and also like BPDPKS, yeah, Badan Pengelola Dana Perkebunan Kelapa Sawit, putting a lot of effort, yeah, that to improve, yeah, not only the oil productions level, efficiency of palm oil productions, but also concerning a lot on the sustainable. I will say that this is our country, and we are well known as the palm oil producers in the world, which is #1. No one can compete us at the moment. Yeah? But with science development, we might lose our positions. However, as I mentioned before, that I saw a lot of good researchers in Indonesia, and also many universities are playing nowadays, are really putting efforts, and also hand with hand, like trying to improve the Indonesian agriculture, not only performance but also productions. And nowadays, to doing export is very difficult because public are require so-called traceability. So it has to be traceable from which oil palm plantation is came from, how it is produced. But this is not only oil palm. Most of the agriculture productions are needed to have the traceability. It means that at an agriculture faculty, we have so many things to do and so many things to teach as well, yeah, for the young, that to be better even than us today. So prospect on developing oil palm Indonesia is huge. How we control the environmental losses and how we control the economic benefits is all depend on us. How that we would like to go. We would like to put Indonesia as in the first rank with a good science, well known, yeah, #1, but also in science, that is depend on us as well also. So I will encourage everybody, in particular also from the Faculty of Forestry and other faculty, to work hand by hand. And also because I am the members of the lead bank of the BPDPKS, there will be now ongoing call for oil palm research, so please apply. And the second question is regarding the refugia or insectary plants. When we are putting those plants, and this is a very common practice actually in the oil palm plantations, there is no need actually to fertilize, because most of these insectary plants are nitrogen fixation plants on one hand, but on the other hand, that the nutritions usually are put or applied by the company are more than enough to support the insectary plants, to support the refugia. So this is not a very, refugia will not play as a competitor to the oil palm. That's, I believe, a lot. Yeah. But we have to be fair oil palm development in Indonesia. In oil palm, there is a 41%. 41% are smallholders. 41% smallholders. For the companies are having a very clear, because they are of course, would like to have high benefits, high profits. So they have a very good standard operational procedures, so having a very clear SOP. But the 40% of the smallholders are having a very low productions of oil palm, are not applying enough, and also not putting enough effort to take care the field, the oil palm field. And this actually are a very nice area for the agriculture faculty in each of the region to play a role to improve the smallholder capacity on oil palm productions, as well as carry on the oil palm sustainability. And good is in one of our long-term research about enrichment, so that we combine trees with the oil palm, and we saw a significant successions of biodiversity. So biodiversity is came back. Our research is not concerning on the small plot. So we are more on the landscape level, so higher level. How that this apply in the landscape level. So that's why from the research, the enrichment plot and the 130 plots cover the whole Jambi province to show a landscape research. That's why I attempted like the oil palm development in Indonesia, and still will continue at least for another 3-4 decades, so another next generation of the oil palm. So, and let's work together to improve the conditions and also to make it Indonesians are more science adoptions in agriculture production. Thank you.
Well, thank you very much, Bu Ayan, for answering the question. Ladies and gentlemen, I believe there are numerous questions remain today, even in this room, in offline. However, we don't have so much time for the first session. And again, I would like to thank again to all of lovely speakers today for delivering very nice and very huge information related to the topic we discussed for the first session. But before we close for the first session, I would like, on behalf of organizing committee, we would like to present the certificate. First of all, we would like to thank to Associate Professor Dr. Paul Christiansen. Maybe, okay, it's already appear in the screen. Dr. Paul Christiansen, thank you very much for your willingness, time, information, and all you present to us today here. Please receive the certificate provided by the organizing committee.
Terima kasih. Very nice. Thank you very much. Just very happy to join in and just wish I was there actually in Palu. And I'm sorry I couldn't make it. And I just echo the comments by my colleagues, Bu Hasnain, about, it's been an enjoyable session. I've learned a lot from both of you. And so it's good. And I would love to get more Indonesian students to Australia, postgrad students, masters and PhD. I saw the big number that you had with the German group. So if we can get a fraction of that would be good. So I think, capacity building, good science and collaboration would be great. Thank you very much to all the organisers.
Thank you very much. We are happy to see you again for the next session. Okay, the second certificate will be presented to Ibu Dr. Husnain. Okay, it is already appear in the screen as well. It's happened again. Okay. Ibu Dr. Husnain, thank you very much for your time, for your valuable information related to the topic that we discussed for today's seminar. And please receive the certificate from the Faculty of Agriculture. Please.
Yeah. Thank you, Pak Darwis, for all the committee of this conference. Very a very fruitful meeting and very important conference. I really appreciate. And Dr. Paul, we are looking forward the new collaboration with us. And Dr. Chua, a very great result. We have to work together. Thank you very much.
Thank you very much. We will send the certificate for you by email. Of course, if you are in Okay, it's working. Please, if you are in Indonesia, we would like actually to hand over directly to you the certificate. Unfortunately, only Bu Ayen are together with us here in the convention hall of the Swiss Bell Hotel, and therefore I would like to ask Bapak Profesor Dr. Muhardi as our Dean in the Faculty of Agriculture, Tadulako University, to give the certificate to Bu Ayen. Please come to the stage. Again, thank you very much for all of you, for all of the lovely speakers, all of lovely participants who are joining us in the first session today. And we also would like to apologize for so many technical issues that we are facing today due to the microphone and others problem in Zoom. So we hope that for the next session we And I would like to remind you, for the next session will be at 2 p.m. All of you are kindly invited to come again here in this convention hall, and also, of course, to joining us in a virtual session by using Zoom. And yeah, it should be at 2 p.m. Central Indonesia time, and it should be 1 p.m. in Jakarta or West Indonesia time. It's same with the Bangkok time currently. It will be the time for starting the second session. And that's all for my side as a moderator for today. Again, thank you so much for your attention, and we'll see you again at 2 p.m. Central Indonesia time. Thank you so much. We give applause to all of us.
Thanks a lot.
Thank you so much.
Sampai jumpa.
Back to the second session, the third International Conference on Environmental Ecology of Food Security. Ladies and gentlemen, in the second session of this afternoon, we will have two presenters who will deliver the information related to our main topic today, the future of food and agriculture. So, the first presenter will be Professor Ingo Graf from University of Hohenheim, Germany. Unfortunately, we just received an information that he has a problem with his health, so very sadly that he can't really join us for today's seminar. However, he already sent us the presentation of Professor Dr. Ingo Graf, and to appreciate the willingness of Professor Ingo Graf to join us today, we show here the short CV of Professor Graf from University of Hohenheim. Of course, we will deliver also the presentation of Professor Graf to all of participants today. And then we will have another talk from Professor Poon Kasamsap from Kasetsat University, Thailand. Before we go there, I would like to shortly introduce him. May I know if Professor Poon already with us? Hello, Professor Poon. Can I have your voice? Maybe there is a technical problem with the microphone. The organizing committee, please turn on the microphone for Professor Poon. Professor Poon Kasamsa.
Unmute, yes.
Okay, I hear. I got it. Thank you very much for joining us here today, Professor Poon. So we are happy that you are here with us. Before you deliver your presentation, I would like to introduce Professor Poon Kasamsap. Maybe this is not really up to date since I just received your CV from the website of alumni of UC Davis University. So I hope later on you can update it when you give your talk. So Professor Poon was a director, or maybe till now, a director of Horticulture Innovation Lab Regional Center at Kasetsat University, Thailand. He is also act as vice president for Kampang Science Campus at Kasetsat University. Please correct if my pronunciation about the name of the university is not correct. He was also, or he is still, the director of the Horticulture Innovation Lab Regional Center at Kasetsat University and associate professor of crop ecophysiology, chair of the Horticulture Department, and the director of the International Studies Center at Kasetsat University in Bangkok, Thailand. So, deliver or present the topic about climate change and mitigation. What else could Thailand do? So, just to briefly inform you, Professor Kasamsap, that our audience here, not only a lecturer from university, we are also university students, and some other from government related to agriculture for sure. So I don't want to talk too much. I would like to hand over the presentation to Professor Poon, please.
Good afternoon, everyone. It's a pleasure to be here with all of you today, and I really enjoy the presentation of the morning speakers. I think it's very significant that this event come at the right time when we have a big challenge in food and agriculture area. And today I'd like to share with you my point of view with my team in Kasetsart University and other organization in Thailand about the climate change and mitigation, and what else could Thailand do. We are trying to address this issue as the private citizen and team of university professors in the past few years. So I will share with you our thoughts. The outline for today is greenhouse gas and climate change and the forecasting impacts of climate change, especially in Thailand, and Thailand biennial update report number 4, especially the land use and the land use change activities. And there are some opportunities for helping the world with the climate change issues. And one of the things that I will talk today is about the open field burning issues in Thailand, and some opportunities there if we stop the burning. And then what else could Thailand do? The remaining things that we should address: the climate smart agriculture issue and the carbon credit. Well, we know that in the past few decades, the world has changed a lot in terms of climate, and the changes are not equal. There are some places in the world that become hotter than the other places, especially the North Pole and the Northern Hemisphere. And Thailand and Indonesia has experienced some of the increase in temperature, but it's not as severe as the North Pole region. But again, it's significant enough that we can actually feel it and experience it by all of us. To me, the most dramatic changes is actually the carbon dioxide. When I finished my study and came back to work in Thailand 30 years ago, I remember it was less than 350 ppm, but right now it's about 420 ppm. And if we look at the record shown by NOAA, NASA, here it's really dramatic that if we look back 800,000 years, we are actually almost doubling the CO2. And we know that greenhouse gas is the main cause of the climate change. My colleague, Dr. Visanu from Faculty of Economics, did the study with his colleague, with his friend in Bank of Thailand and other institutes, and they look at the forecast of the impact of climate change on major economic crops of Thailand. For example, rice. You have the baseline production in million tons in the left, and what happened with the scenario RCP 4.5 within about 20 to 30 years period, the rice would be greatly affected. The yield will decrease by 10%. And if we use the scenario RCP 8.5, it will be a reduction of 13% in terms of yield. When we look at sugarcane, one of the major products of Thailand, we could see that the sugarcane will be a lot more affected, 25% decrease to 35% decrease within 20 to 30 years time. And then cassava, 15% to 21% yield decrease in 20 to 30 years time. You will see that the effects vary among provinces of Thailand. It depends, because even though Thailand is not a big country, much smaller than Indonesia, you know, the effects can actually vary a lot. When we look at rubber, we could see that the yield would decrease for the whole country by 5% to only 3%, which doesn't seem much. But there is another study, preliminary study done by colleagues from France, from CIRAD, with funding from different sources. And this has come from the project that we call 4C. It's forecasting the impacts of climate change and labor limitation. That we actually plan to have the kick-off meeting in Kasetsart University tomorrow. So I think we will review this forecast again in the next 5 years to see if we could do more than what we have been doing in the past decade. The point is, the project will look at the changes in climate and its effects on rubber in Thailand, in Vietnam, and Cambodia. And it's not just the changes in climate, but it also look at the effects on the rubber using the composite climatic marginality index done by Dr. Eric Goe from CIRAD with his colleague from Vietnam, using the annual mean temperature, annual mean rainfall, and number of months of dryness, number of months of cold, and thermic altitude, the maximum minus the range of temperature, and then I just show you one picture. This is the picture of their prediction that actually the rubber can be heavily affected. You could see that right now, the southern part of Thailand is probably the best area to grow rubber. But with this scenario IPCC SP 2-45, it will become a lot less favorable to grow rubber as soon as 20 years. And, you know, in 30, 40 years, it will be even much more affected. So climate change will affect 10% of Thai population that make their livings on rubber within only a few decades to come. The point that I want to make today is that the land use and land use change activities have a significant effects on the greenhouse gas of Thailand, especially when we look at the inventory. I took this from the report, the biennial update report of Thailand that were submitted 2 months ago. We could see that right now, not right now, we just made the report, but the report dated look at the greenhouse gas inventory in 2019, there's a lag time of about 3 years. We would see that Thailand greenhouse gas emission overall, excluding the LULUF sector, is about 322 million tons of CO2 per year. And that is significantly increased from almost 20 years ago. It's about 45 to 50% increase. And if we look at the changes all over the years, we could see that the emission part is on the positive number on above the zero line. And then the green part is the LULUF sector that have the net removal of the CO2 and CO2 equivalent of methane and nitrous oxide, of course. And it's probably the only sector that Thailand has reported to UNFCCC so far. If we look at the agriculture side, rice growing has become one of the biggest greenhouse gas emission in agriculture sector, 28 million tons CO2 equivalent. And because rice emitted methane. Okay, and right now, the second highest emission come from livestock, 14 million tons, with the manual management of 3.2 million tons and enteric fermentation of 10.8 million tons. And then we have the managed soil of 11 million tons. Urea and fuel burnings almost equally contribute for 1.4 million tons. So what we call in Thailand is a big fish. It's actually rice, methane production, and livestock also methane production. Okay, and then we have the managed soil of methane and nitrous oxide. Okay, but the green part of Thailand greenhouse gas accounting is really the LULUF sector has a net removals of about 92 million tons of CO2 equivalent, with rubber contributing the most, 75 million tons CO2 removal, and the rate is about 0.7 tons per hectare per year. And we have 3.6 million hectares of rubber. So I haven't looked at the Indonesian number yet, but I guess Indonesia would probably have roughly the same number, because I think maybe Indonesia has more rubber acreage than Thailand now. But when we look at the forests, we have a lot more forest area in Thailand, 16.3 million hectares of forests, with agroforestry of less than 1 million hectares. And the forests account for only 25 million tons net CO2 removal. So these two sectors really help Thailand to have a lot less net CO2 emission than the numbers that we don't have rubber and forests. So the opportunities for Thailand is to, one thing, the first one is to encourage more agroforestry, invest more in managing the rubber plantation, the oil palm plantation, and fruit trees plantation. You know, the easiest way to approach carbon neutrality for Thailand is to make sure that we count the number of hectares of trees to be as accurate as we could, so that we remove the burden from our industry, and the country, that we can approach carbon neutrality a lot earlier than we could without the trees. And the way to do it is a lot cheaper than investing in the CDM technologies in different sectors. But if you look at the fast-growing trees, we have eucalyptus. This is the tier 2 country-specific data. We say that eucalyptus removes 1 ton of CO2 per hectare per year, while rubber removes 0.7. The fast-growing trees in Thailand, in the tropics, and I believe in Indonesia may even grow faster and remove more CO2 than in Thailand, because you have a lot more rain and less drought period. But these are some of the trees that should be configured as one of the ways that Thailand can approach carbon neutrality faster and invest a lot less more than other options. What Thailand has done in the past few years was to change the law, amend the law to allow the people to grow 58 species of trees and to cut them legally now. In the old days, people can grow teak, but they cannot cut the teak unless they ask for permission from the government, which is really tedious and time consuming, and they don't easily give the permission for the normal people to cut the teak. So in effect, they can grow teak, but they cannot cut the teak to sell anything. But right now, it's a lot easier. I think we are making enabling policies to allow us to grow more trees, and this is one of the way that we want to do it. But I want to bring your attention to rice. We all know that rice been painted as the bad crop that produce a lot of methane, right? So in Thailand, rice produce about 28 million tons of methane, but in this figure, I still use 26.6, which was the number 2 years ago in BUR3. But we use eddy covariance method, the same method that Ian used to study oil palm in her plantation in Indonesia. And we found that even though rice produce methane, rice also sequester a lot of CO2. And from our data, we project that all of the rice growing area in Thailand remove around 200 million tons of CO2 equivalent per year, compared to only 26 or 28 million tons of methane in terms of CO2 equivalent per year. If we take into account of the 5 to 15 million tons of CO2 released by burning, and 30 to 40 million tons of CO2 in rice grain being harvested every year, we have the net sequestration of CO2 by rice field in Thailand around 120 to 140 million tons every year. But this world doesn't count the CO2 sequestration from rice fields, because they say that all the carbon capture by rice field, the annual crop, would be released in 1 year. But I strongly dispute this, because when we put the eddy covariance equipment, we also measure the degradation of the carbon captured by rice from last season and last year. So what we plan to do is to monitor the rice fields for 5 to 10 years and use it as a research evidence to dispute that that rice is really a bad guy, but in reality, it's really good guy for Thailand. It removed net 120, 140 million tons per year. You know what? I cannot.
Professor Poon, are you still with us? We don't hear your voice. Hello, Professor Poon?
Hello, can you hear me?
Yeah,
Okay.
we got it very clear. Thank
Okay,
you.
sorry. Please
No.
remind me, because I don't have the clock, because I use my telephone to speak through my telephone here. If I run out of time, please remind me. Okay. We have the open field burning issues that not only the greenhouse gas emission, but also the PM 2.5 serious health issues for Thailand. And we have a committee that was set up by the office of the Prime Minister, and we gave them advice. The PM 2.5 is really serious for Thailand. And in the northern part of Thailand, we have the issues of lung cancer higher than the average Thai citizens all over the country. And the reason is because there is a lot of agricultural burning area, with rice being the highest area burned. And we have corn, and then sugarcane. Okay. But what is really disappointing is the forest area. You could see this map. It's made of the repetitive burning area in the forest. Well, it's actually for all over Thailand for the 22 years period from year 2000 to 2021. And we have the biggest four areas with the most frequent burning happens year after years, and these are in the national forests. These are in the protected area, and we've been working in one of the area for 4 years, and we expand to all 4 areas. In fact, we expand to all over Thailand just last month. But you could see that just across the border from the north western part of Thailand, you could see a lot of the red color from Myanmar, that they burn a lot of land area. And tell you what, it could be Thai people to blame, because I think the Thai business move corn production to Myanmar, and in Myanmar, after they grow corn, they burn. So the smoke from the burning was carried by the wind and affect Thai people and affect Myanmar people. So this is one of the issues that we have to do. We have to stop the burning. And in order to do that, we have to address the food security issues of the people. This is in the middle of this picture is the national park called Mapping National Park, the area that I and my colleagues been working in the past 4 years, and we have tried to identify the cause of the burning. And so far, we have identified that the burning, the yellow areas, because of the hunters use the river to travel and burn the forest to scare the animals to run down to their camp so that they can shoot easily. Okay, and then what happened? Should I share screen? Okay. And the second most important issue is the burning by the villagers, that they experience a dry period of 6 months every year, so they have to go into the forest. So the not too difficult ways to stop this kind of burning is to help the farmers help the villagers with the food security issues. So that's what we've been trying in the past 4 years. And this is just to show you that the application called Tamfai, following the hotspots, so that we know where the cause of the first fire was, and then we can go to the village or the field that's lit the fire, and then talk to the farmers. The other opportunities would be the climate smart agriculture. There are a number of issues that we have already done, but there are still a lot more opportunities to do. The point is, when we want to push the activities, the good activities, we need to provide incentives to the people. And the way to do it is to make sure that the innovations and technologies that we want to promote would benefit not just to us, but to the farmers and to the people in all sectors. And we need to communicate this very well. We just begun the new project with the support from USDA, using technology to support Thailand's transition to climate smart agriculture. And we hope that this one could help us import new innovations and use it, so that we don't need to reinvent the wheels, and we may be able to go faster in the scaling up the climate smart agriculture in Thailand. But the most important ones that Thailand's been pushing in terms of enabling policies is the carbon credit. We have the Thailand Voluntary Emission Reduction Program, we call TVER. It's a bit, frankly speaking, I think it's a bit late compared to Europeans and Japanese and American colleagues. But again, they are accelerating their efforts now, especially in agriculture and forestry. In agriculture, they have the methodology that's accepted by TVER, the Good Fertilizer Practice in Agricultural Land, and they have the carbon sequestration and reducing emission for perennial crop plantation, which has received a lot of attention from many people. Their phone rings non-stop all day long. But again, I think the process took too long. And in forestry, they have sustainable forestation, and also the reducing emission from deforestation and forest degradation, enhancing carbon sequestration in forest area project, large-scale sustainable forestation project, and agroforestry, the fast-growing tree plantation, which I really believe it's the future of Thai farmers in Thailand, because we have around 25 million hectares of farmland that I think 20 million hectares out of those 25 are in low productivity. If they can move to agroforestry with the carbon credit, and it will move to the sustainability side of the equation right away. The transition is going to be need to be planned carefully, and the policies would have to be changed and updated and modified as fast as the situation requires. In Thailand plan that we submitted, in Thailand plan we right now Luluf sector have a net removal of 92 million tons, but they only plan to increase it to 120 million tons in 20-25 years. What we are pushing is for them to double it. In fact, we are asking them to increase to 200 million tons per year. And believe it or not, I think it is possible. Well, I know we have, I know that I have the German speaker following me before. So I intentionally bring this. We have the help from the German government to invest in the NAMA project, the Nationally Appropriate Mitigation Action in Thai rice. They plan to reduce 1.2 million tons of CO2 equivalent in 5-year period. And the budget is very, 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 very high. But again, it's alternative wetting and drying of rice, the site-specific nutrient management, the soil analysis, the leaf analysis, so that you have the tailor-made fertilizer program, the crop residue management type. This is one of the good project, but it's a bit difficult to scale up. And then we have the carbon credit projects. We plan to put in the eco-variants tower in this repetitive burning forest area, so that we can follow the carbon sequestration increase after the stop burning practice. And my last slide, a number of Thai organizations, especially in the big ones in the stock markets, joining hands to invest more in carbon neutrality. I think they are forced by the buyers abroad, like CBAM from European countries, for example. But again, it's a good initiative. All right, that's about all. I hope I stay within the time limit. Yes.
All right. Thank you very much, Professor Poon,
for sharing such valuable information related how Thailand mitigate the climate change. And we would like to continue to the discussion part. And therefore, we already have one question from the online participant. I would like to share it to the screen. I hope you can read it now.
Yes.
Yeah, Professor. Yeah, Pak Iko Mangdamarjaya asking about what practice in climate smart agriculture in Thailand that reduce the greenhouse gas emission a lot. Maybe you can answer it directly, Professor Poon, please.
Yes, it depends on the people who ask, and then who you ask. If you ask people in the government, in the Ministry of Agriculture, they would say that reduce the fuel burning in agricultural land would be the highest impact in climate smart agriculture. someone who say the alternate wetting and drying circle in rice water management, allowing soil dryness for only 2 weeks would reduce very significantly the methane emission. Some says 50%. And there are carbon credits opportunities already in this alternate wet and dry cycle. A Swiss company or Swiss organization has already offered to approach Thailand rice farmers to give the credit if they follow the alternate wet and dry. But
Hello. Maybe you have a connection problem. We can't hear your voice. Hello, Professor Poon. We can't get your voice now. Unfortunately, we still don't hear you. Okay, so currently Professor Poon maybe have a problem with internet connection in his mobile phone. So while he is preparing for fixing the problem, I would like to ask if any question from the floor here in offline participant, maybe any question that can be collected. Okay, Pak Henry, please. Maybe you can hear us, then you can also note the question at the moment, Professor Poon. Please, Pak Henry.
Yes. Yeah. Thank you for nice presentation.
Pak Henry, maybe you can use this one. Yeah, still a problem.
Yes. Yeah. I would like to get your experience or information about how the government or the research institute to handle this mitigation or adaptation. For example, in the rice field in Indonesia, we reduce unorganic fertilizers such as urea or NPK and substitute with, for example, in the rice field, 5 ton compost per hectare. So, do you have any other experience, for example, that you saw modify fertilizer application or soil tillage management and so on?
Okay.
Thank you.
Hello.
Okay, I am back online. Sorry for the interruption.
Very much for joining us again.
Okay, I think I have the telephone issues. The easiest, the biggest return on investment for climate smart agriculture is to actually extend the life of rubber plantation. You know, Thai rubber sequester 100 million tons every year, but we return about 25 million tons back to the atmosphere because we cut down the rubber trees. So the net sequestration for rubber that we report annually is 25 million tons. And the way to reduce the CO2 emission from cutting down the rubbers is to adopt the low frequency tapping of rubber. The old methods allow Thai farmers to tap rubbers for 20 years. But normal Thai farmers tap rubbers for only 12 to 15 years because they use the tapping techniques that has a large bark consumption. The new method practiced in some of the fields in Indonesia. I know this because I sent my team to Indonesia. It's a Sofindo plantation in Indonesia. The new method can extend the tapping of the virgin bark to 30 years. So it is going to be a sustainability growing of rubber. You can grow rubber for 40 years easily. Similar to what Ian mentioned to you about oil palm. You know, if we have trees in agriculture and we can have the methods to lengthen the harvesting years, the return on investment in terms of helps to climate is very significant. It's the more significant. Thank you.
Okay. Check. Okay. Thank you very much for answering the question, Professor Poon. Is there any more question from this room? From the chat box. Can you?
This is a long question.
Okay, please.
What is the ideal combination between agroforestry, palm oil, other crops? I think the best combination depends on location, and it's not just the physical location, but it's the socioeconomics. Like you said, there is no standard formulation in Thailand. I mentioned to you the 58 species of valuable trees, right? The valuable trees species that Thailand would allow normal people to cut down and sell. We are trying to push the government to set up experiments fields, long-term experiment fields, so that we can have we can try different combinations of species. But I can tell you this. One of the most interesting combinations that I found is not amongst different species of trees, but the combinations of trees with mycorrhiza. Because there is a mycorrhiza in Thailand that makes the mushroom very pricey, very expensive mushroom, and it's only associated with certain species in Dipterocarp. So this is one of the best combinations, so that within 2 or 3 years, the farmers that grow the trees, dipping the trees root with the mycorrhiza culture and grow it, they can start harvest the mushroom, expensive mushroom, within 2 or 3 years, and then they can have steady income right after only 2 or 3 years after they start growing the agroforestry field.
Thank you very much again for your answer. Since it is related to the oil palm ecological aspect and socioeconomics, which is already presented also by Bu Ayan in the presentation, do you want to add some point of view, maybe? Bu Ayan, are you still here? Hello?
Ayan, or you want me to say something, or you want Ayan to
I'm asking
say
because
something?
you already present such a topic related to this question right now. So maybe you want to add some point of view related to your topic this morning. Do you want to use the microphone? I can come to you. Tidak mengambil.
Yeah, thank you so much. But I think Pun, you can first add some of your comments first regarding the questions. What do you think? Would you like to share?
I think for oil palm, the most important issues that I trying to push Thailand to do it is to use the dwarf cultivars. That's like you said, it can extend the harvesting periods very significantly. I don't know if we can do the combination between agroforestry and palm oil, because I never seen one in Thailand, frankly speaking. But Indonesia grow a lot of oil palm than Thailand. Maybe you can add more. Thank you.
Yeah, thank you. It is true when we can expand. Sorry. So when we can expand the life or the life cycle, we might reduce so-called global warming potential of the impact hectares. Regarding the combination of agroforestry, as I mentioned in one of our research, long-term research, and still existing, so-called enrich oil palm with trees, 6 agroforestry trees, so it's from durian, so durio, till petai, and so far they are growing very well in our plot. We have 52 plots, and Pun, you are invited to visit this plot actually. So if you have time,
Thank
come
you.
over to Indonesia. And we planted in 2013. And so far until now, we did not see any reduce of the yield collections of oil palm. So far so good. And talking about the kinds of balancing between ecological situation or ecological benefit and economic benefit, of course, this is a very difficult, not easy to calculate on that. However, the successions in our plots by combining trees are strongly improved. So I believe this will be a way out. The experiment is so-called a kind of island. And so we are starting to make an island of biodiversity, island of diverse in a monoculture, so in a sea. So that when you have a huge landscape of monoculture, we are trying to put many small islands of biodiversity. That's the idea of our research. So we are quantifying the succession, the microclimate, the economic benefit, and regarding to the questions, whether when will be the balance is quite difficult. So I will say that we invite everybody to do the research with us, also to visit our field. This might be very interesting for everybody to see. So when is the midpoint? No idea till now, because it's now a kind of 9-10 years of research, and I think the valuation shall be done a kind of 20 years. But I'm very happy that our research is now adopted in many ways. So perhaps we are also the first group that to convert the research in a kind of art. So for socialization domination, so that we are convert the research activity to a kind of art performance last year, and attracted quite many numbers of people and international partners who now we gain some funding, extra funding, to build a kind of sustainable village. So this sustainable village adopt the research result by us, but at the same time, we put a PhD student to study the adoption of these processes. So this is actually a very interesting point as well. So Pak Budiaman, so you are greatly or invited to join this research as well as to visit. So thank you.
All right. Thank you very much, Bu Ayan and Professor Poon, for answering the question. Is there any more questions from here? Please. Silakan Pak. Sorry, we mix already Indonesia and English.
Thank you very much.
Could you please stand up? Then your picture can be recorded by the camera.
You have very nice presentations. But the thing I would like to ask from you is that you didn't touch about the uncertainties to the sustainability. How Thailand reacts to uncertainties like earthquake, floods, or something like that, particularly to the rice farmer. Thank you very much.
Oh, it's thank you very much for the question. It's a big issue. I think we have experienced more extremes climate a lot more often now. Last year we have the big flood, and farmers are heavily affected. Point is, the government has never ever been able to compensated fully for the loss, and the way that the government has done is to address the situation and try to help in the humanities area. But to prevent it, it's just not easy. 12 years ago, we had the biggest flooding in history of Thailand, and that was because of the mismanagement by the government. Because they withheld the water from one of the biggest dam for too long, so the water overflow in the later season, and then they have to release all of the water. But I think in the past 10 years, it's because of the climate extreme. Now, I don't know, the government has an insurance program for the flooding, for the drought. But frankly speaking, the insurance program is too little, too late. Too little is not fully compensation, not a full compensation. Too late is the money would come a few months after the events end. When I talk to my Dutch colleague, they say that the insurance, the agriculture insurance program would have to pay out within 15 days so that the farmers would have received the funding soon enough to make the difference. They can put the insurance money to work to save their farm, for example. So we are still a long way to go. But again, on the other side, we can say that we have seen rooms that we can improve, but improving the risk management is not easy at all. And when it's climate risk management, it's not impossible, but we have to do the best that we could with the limited resources that we have. Right now, there are applications that the farmers can draw their field in their own mobile phone, and they can have the risk assessment from drought, from flooding, and from soil, salt soil, acidic soil, and different kind of risk issues. The rainfall, the temperature warnings, they have their numbers. They have access. They can have access to this kind of applications, but this is based on the past data. We don't have the ability to forecast the annual climate and 6 months, 3 months, 4 weeks, 2 weeks, 1 week's climate as good as we should. Well, we are not satisfied with what we have, even though the government is providing the new updates to their apps. But I can tell you that we still have hope, very good hope on these issues, because I think the advance in remote sensing has already helped us a lot, and Thailand just got a new should get a new satellite coming very soon, and I think it would help too. Thank you.
Well, thank you very much again, Professor Poon. Ladies and gentlemen, I believe there are some more questions left. Again, unfortunately, the price. And I have to say thank you very much to Professor Poon for joining us, sharing valuable information related to our topics today. And from the Faculty of Agriculture, who's hosting this event, would like to present a certificate for you. So here is the certificate. I guess it's already appear in your screen as well.
Thank you very much.
You are
Most
welcome.
appreciated.
Yes, we will deliver the certificate by email to your address. And then again, from the organizing committee side, we would like to thank you very much for all of your preparation, joining us and sharing us for today to all of the very valuable information. Thank you very much. Ladies and gentlemen, actually we have two speakers for today. As I informed at the first time for this second session, that Professor Ingegras very apologized for us. Actually, he would like to join us. He already sent us the presentation for his talk today. Unfortunately, he has healthy issues, and therefore he can't present his topic for today. But he already sent the PDF presentation, and we also will share it to all participants who join us both offline and online. So that's all our keynote presentation for today. On behalf of organizing committee, we would like to thank you very much for your valuable time, attention, on all of you share with us here in this lovely seminar for today. And the next agenda for today will be the Dean meeting for Faculties Association in East and Central Sulawesi. Okay, before that, I would like to thank you again. Apologize for many technical issues. Assalamualaikum warahmatullahi wabarakatuh. I hand over the mic to the